Wow, what a beautiful night. Hey everybody, how are you? This is Mark D'Antonio, your SkyTour LiveStream Mixmaster, or whatever I am. And I seem to think there's someone else hiding in the wires here, and I think it might be Daryl. Daryl, you're here, aren't you?
Yes, hello, Mark. Hello, everybody.
Daryl and I are going to take you on a little survey of the night sky tonight, and we will, of course, look at Mars later on. It's going to be, it's up now, but it's got to get a little higher in the sky. And it's sort of to the left of the moon, but if you saw the post that I left on Facebook and in SkyTour Livestream and on about 25 other locations, you saw that we no longer have to really worry about the moonlight because we have a filter that will knock out the moonlight. And to prove it, I took a photo of the Eagle Nebula, which is Messier 16, and it was only a few degrees from the moon. And the moon was first quarter, not full, but it was first quarter, and that's still a lot of light. And the processed photos of the Eagle were beautiful. This filter, it's we have several filters that we use. This one was called a narrow band filter. It's one of two narrow bands that we have, and it was actually quite good. Now, for those of you that haven't been here before or have been here and want a reminder, this is the telescope control section. This controls the telescope up here. You're looking at it up there. Okay. This is the access to the computer where I do computery things with the telescope, and this is the focus system. And down here we have the filter wheel currently, and you notice right there it says narrow band 2, and we have narrow band 1, which you can see when I do this. Let me roll that filter over. And now you see that it momentarily blinks, and now it's narrow band 1. This is the narrowest narrow band. That's a tiny slot through the entire spectrum of color. This is just a tiny slot at various spots that are very important to us in astronomy. Narrow band 2 is slightly wider areas in those very important bands within the spectrum. And then there's 5 total filter slots, and right now I have one that has nothing in it to allow you to look straight through with normal light, but of course tonight it'll be just awful because the moonlight is like, huge. And we also have one that's just black, so that you could take what are called dark frames, so it's like putting the cap on the camera and taking pictures. And then I have one that has a spectral gradient in it, so I can actually see colors. I can show you that one because Jupiter would actually do that quite well. So let's go. This will be, you'll see it blink for a minute. There's narrowband 2. It lets in slightly more light as it's those wider ranges. And then the spectrum looks like this. Ooh. And you might say, wow, that's pretty, but what does it do for us? Well, if we were to analyze and take these, just a section of this spectrum in to this particular program that we use here in SkyTour Livestream called RSpec, we would actually be able to see the elements that are in the atmosphere, not of Jupiter, but of the sun, because Jupiter is reflecting sunlight, and it's reflecting sunlight that has already had the information taken out of the spectrum by all of the elements in the sun's atmosphere. And so we would actually be able to look at that spectrum. When we looked here, this is called the Fraunhofer Spectrum. And I don't think we could see it just directly live because it's really quite bright. We'd need a program to actually decipher it, but you can see the lines we're looking for would be like little dark lines that go across the spectrum like this, and we would see some of them. But this is really just really pretty, and so that's what that wheel is for. Okay, and then coming back to narrowband 2, that's the somewhat wider cut through the spectrum, and this is the narrow cut through the spectrum. You notice how Jupiter is as dim as it'll be with this filter. But what I could do is drop down the exposure. So finishing out with you, this is the whole telescope control section and the filter section. This is me, hi, down here below the image of middle of the telescope. Gotta hold that up. And over there, okay, over here is actually, this is the camera control group over here. We have, you have your exposure time of 25 seconds right there. We have our ISO, or our camera speed, right there. All right, And then down below are some other factors that only I care about. That's our new logo, by the way, STLS, ta-da, yay. Okay, and then down at the lower right over here, this is a peek into the observatory live to show you what's going on with the telescope with this low light camera. This right here is actually the telescope cover, and that telescope cover is something that we've actually, it's an automatic system. And this is the exact same telescope that is going to Arizona. I know I keep saying that for those of you that hear me, but I was supposed to be in Arizona today and for the last several days. I'm not because of COVID once again, but it hasn't stopped the construction. The observatory construction is now underway, and I've been working long distance to help people figure out what they're going to be doing. And it's really not pretty sometimes. We already fired our first observatory building company. I didn't want to, but they basically tried to foist off trying to tell us that we couldn't do what we wanted to do. Yet for 6 full months, we've had in the contract exactly what we want to do. They just didn't read it. Oh, bad idea. So I basically said to them, well, perhaps you are not the ones to build this observatory then. And they're like, well, wait. I mean, we could talk about this. I'm like, yeah, you know what? If you're trying to play these games, then you're probably going to cut some corners. I can't afford it. I said, I'm going to have a lot of people that are going to be watching and depending on this thing working right. I am not going to put that at risk. You guys mean a whole lot to me. And the fact that you're willing to stick around and watch, well, I'm telling you, that's very important. So, I have someone else now. It's actually a friend of mine who is going to do everything. He's going to build the observatory and the roof roll-off. It's a roll-off roof mechanism, so they have the building. Okay, if this is the building, okay, the roof's going to roll right off, exposing the interior and the telescopes, and it's going to come back on at the conclusion of the night. All remotely operated, and I've written a program to do that. And so we will see how it works. So I think that that'll be great. So I just want to say hello to everybody. Hey, Genghis and Terry Groff is here. Gina Leone, what's up? Foggy Range, how you doing? Tara's here too. I saw her. And we have Carmelta Burks. How are you? I don't know that you didn't miss anything, Carmelta. We actually, or is it Carmelita? I don't. You can't really tell. I think it's. You'll have to tell me how to say it because it looks like it says Carmelta. So maybe it's Carmelita. I don't know. Anyway, it's so nice to see you here. I think this might be your first time. I haven't seen you before. If it's the first time you sent a message, excellent. This is Jupiter. We're going to look at it some more, and I think we're going to have a good time. Hey there, Big Crunch. How are you? Big Crunch. That's actually one of the theories for how the universe can end. Kind of not in those exact words, but kind of, sort of. We have so much mass in the universe, it's expanding outward, and now we find it's accelerating outward as it goes. And as that goes outward, you would think it might slow down, come to a halt, and then its mutual gravity inside all of this might pull it back in, and boom, and it might be a pulsating universe known as the oscillating universe. Well, that also is preceded by the big crunch, where everything goes back together and smashes in together. Can you imagine you're a life form, you just crawl out of the ooze and you go, oh, wow, hey, this is kind of cool. What's that bright light? Why is it getting brighter? That's the universe crushing in on itself, and you're just about to die. It's like, oh, I'll see you next round. And Farva's back. Hey, man, how are you? I love it. Really nice to see you again, Farva. Thank you very, very much, by the way, for the donation. That's very kind. I really enjoy all of you guys. So I've given you the tour of the screens. This, of course, is the live screen right here in the middle. This is the live screen, and I can get rid of most of this stuff. What I'd like to show you, I have a focusing mode too. When I want to focus on stuff, what I can do is I can move the objects I want to look at into a location for doing specific focus work. So that's this right here. So here's where I bring in Jupiter and focus. Now I've already pre-focused it, but it's kind of bright right now. So what I'll do is I will drop down the sensitivity from where it is now at 4,000. I'll drop it down to 50. Okay, and by doing that, that'll give us the smallest film, the smallest what they call film grain. It's really not film, but the noise we call it now these days. You'll notice the moon seems to drop away. That's because of the fact that I'm dropping down the exposure so that we can see the cloud bands on Jupiter. And sure enough, you can actually see the beginnings of the cloud bands on Jupiter. Let me move this over for you so you can see it a little better. All right. That's the wrong way.
That was Ganymede on the left and Callisto and Europa on the right.
Oh, let me bring that back just so people can see that again, Daryl, because thank you for that. Yeah, tonight we have 3 of the moons on the right, and you might say, well, wait a minute, I don't see 3 on the right. Not anymore. But when I started earlier tonight, there was another one over here, and that was Io. I'm not sure if Io is going behind or it transited. No, actually, I think it went behind.
Yeah.
Yeah, and then we have, you said this is Ganymede over here on the left. Is that what you said?
Yes, Ganymede on the left. Interesting, in an hour from now, Callisto's shadow will be on the face of Jupiter.
Ooh, well, this is Callisto out here, isn't it?
On the right side, it's the one closer to the planet.
This is Callisto? Okay, then that means that Callisto is...
Callisto is moving from left to right. It already passed over the face of Jupiter.
Right.
And its shadow will be following it starting at the upper left-hand side.
Well, we should be looking for that then.
In an hour or so.
We should be looking for that. All right. Now let's actually. So that's that, and then Europa's right here. Now Europa is this guy right here, and this is one of the most interesting moons in the entire solar system, because it's possible. And for those of you that don't know, when I was 9, I realized I was going to be an astronomer, and I never stopped that, and I pursued it, and I got my degree in astronomy, and I've made it my life. So, planets around other stars are the thing I specialize in. Outside of academic work, I don't work in an academic institution. I actually run observatories. I have one here in Connecticut. We're building a second in Arizona, in the desert, and it's SkyTour LiveStream, which that logo in the upper right corner shows you. Okay, SkyTour LiveStream is remote operated facilities, and the one here in Connecticut, I'm in a warm room. I'm not in the observatory. I used to be when I first started, and I slowly converted over to I started to convert over to this process of automating everything. So it looks good, it works well, and we're going to be using it extensively out in Arizona. Let me just drop us down now, and we're using filter number 1. Let's try that. That's the narrowest of narrow bands. That looks a little blue. This is a 0.8 second exposure. Let's see what this shows us. First things first, let's get rid of any of that, and let's go into this. Okay, let's see now if we can. Okay, the filtered view of Jupiter, we actually see those cloud bands, and the zones are white on there. It's really pretty, but I'd like to add a little more realism to this, a little more realistic color. So what I'm going to do is I'm going to get out of, I should say, narrowband 1. We're going to go to narrowband 2, and now Jupiter will look a little brighter. Okay, and I'm kind of in the way here, I'm sorry. Alright, so what I'll do now is I will shorten the exposure a little more, because it lets in more light when you have a filter that allows in a little bit more light. So we're going to drop this exposure down, and we will now go ahead and take a 1/5 of a second exposure Oh, okay. Now we're seeing something. All right. Look at that. That's beautiful. You can clearly see a lot of differences inside and in here. We can actually see 1, 2, 3, 4, 5 cloud bands. Earlier tonight, the red spot was right about here, and I think it's gone around the edge right now. I don't think we can see it now. But it was there. It was gorgeous. And Ganymede, being the largest, actually the largest moon in the solar system, well, Ganymede is right here. You can't miss it. Okay, there it is. And Ganymede, even when you're exposing properly for Jupiter, Ganymede is still showing up. And the reason it's still showing up is because it's so large. So it has a lot of surface area.
Bigger than Mercury.
That's right. Exactly right. Bigger than Mercury. Yep. And as Vera says, Darylpedia strikes again. I think that's great. Hey, deal with it, Daryl. You know stuff. What can we say?
I'm a regular Cliff Clavin, I'll tell you.
Hey, they're normie. Yeah, Cliff Clavin. And if nobody gets that, well, cheers to you. That's a joke because the show is called Cheers. Cheers. Tara D says Jupiter Blues. Yeah, look at this. This is really pretty, though. This looks nice, Daryl. This really has a nice look to it. I can actually sharpen that a little bit. There's a little sharpened auto view that I have these specific views I can set up, and I set up a sharpening view so we can sharpen the detail just a little. So that's without, that's with. Gives you a little bit more detail. That's pretty, huh?
It is.
Yeah. Wow. I'm thinking maybe a couple more shots. Let me try doing a little bit. No, this is a good exposure, and I'll go do another one. And yeah. No, what I'm not doing, guys, you'll notice when we go into this, okay, this is, okay, this view right here, this is the actual size of Jupiter in the telescope, okay? We're shooting at what's called prime focus. So over here, okay, the telescope, all right, has a camera on the back of it, and on the burly back of it, that's using this telescope like a giant telephoto. So that's what's going on here. What I could do, and Daryl suggested this, I've tried it, I have a setup for it, is to actually insert an eyepiece into a little barrel and then put the camera on the telescope. And that will give us a really magnified view. But it's a setup which is, you got to tune it just a little bit, and it's not perfect. And I've tried it, not happy with what I'm getting. So I'm working on a way to actually do optically magnified views without doing the eyepiece projection and having that take up the telescope's location. It's almost like the telescope's position, I should say, because that eyepiece and that lens has to be in there just so, and then you can't do anything else with that. You can't do a wider field at that point because now you got that eyepiece in there. So you got to take the eyepiece out and go back to that prime focus like it is now. There might be a way to do that without having to do that. And I'm looking into some methodologies for doing that now. There's a lot.
All right.
Yeah. You know what I mean, Daryl? I mean, you've seen the turret head telescopes before. And that's kind of where I'm going, to have like a turret that'll rotate through. The other possibility, which is kind of crazy, is, and this is something that I know works because I use a telescope like this. You don't have a camera attached to the telescope at all. You've just got cables coming out of the telescope. And the camera is elsewhere. And the image still goes to the camera via this cable assembly, which has carrying the signal. And then from there, you could actually electronically put in any device you want. You could literally add anything into the light train, a spectroscope, a grating, or a plain view like this, filtered views, and you can actually do that. So there's a lot of possibilities. So I'm not, you know, that's down the line though, because that's really, it's a feat of engineering. But it's worth it if you can get it to work. Then you're up to, then you're up to an actual professional grade research telescope, which is, but it's not, you know, the highest end yet. So I'll use my knowledge to do that on a higher end system when we can actually get a higher end system. For now, we got this. This is how big Jupiter is in the eyepiece right now, but it's okay because we don't always look just at Jupiter. We also look at other things, you know. This is the preview screen. Okay, down here are pictures we took earlier. I can turn off our camera in the dome, so you can see I took a lot of pictures earlier tonight just to do some testing, right? And not all of them, you know, came out perfect, but that's okay. I was trying to do some other things. I also took some when it was just getting dark and testing the resolution. Okay, here's a faint globular cluster that I was looking at, and so forth. And I show you just the main screen, okay? But if you want to see this other one, you just complain, and I'll be happy to keep this up there too, and we can go back and forth from it because I like you to see everything. All right, so the last thing in our foray through looking at the sky and looking at our setup here is this. This is our live planetarium. This is attached to the telescope, and wherever we tell the telescope to go, that's where it's going to go. So, for instance, if we say, let's go to Saturn, I can click on Saturn right there, and then I can tell it, okay, go to Saturn. Now watch Jupiter. This is a live view. Watch what happens when I tell it to go to Saturn. Okay, I told it, and goodbye, Jupiter. So now we're off to Saturn. And if you notice our dome cam, you'll see that the dome cam is now moving to a new place. The scope icon that you see on the screen, it's actually gone. The scope icon that you see is actually incorrect. I'm working on how to fix that, but it is doing the right thing. It's going to the right place because there's Saturn. Right, and what we'll do is I'll just start opening up the exposure a little to make it a little brighter, and we'll see the ringed planet, all right, in just a moment. Okay, so now what we'll do, we can bring it over. Let's head a little east. All right, there's a little bit of eastern run there. And I believe it's focused, but we'll do a focusing shot there. So this is not really the eyepiece projection thing I was just telling you about, where you put an eyepiece in. This is just a digital zoom. So you only get whatever pixels are in this little area, which is why the cursor's so big. Okay, so as you can see, if I'm doing this, all right, and I do this, you can see what's going on. I've just taken a little piece here to actually focus on. Well, there. So now, let's go see how Saturn looks. We'll do it's going to be a 0.6 second exposure at 50 ISO or sensitivity. Okay, and let's see what we get. It'll be instantaneous, and it's done. And there it is. Now let's go look at it, shall we? And see how Saturn looks. And we'll also take some photos of the moons as well. Look at that. Wow. That's pretty. You noticed, you know, if you look at Saturn real close here, you'll see right here. Get out of there. You see right here, you see this. This is the shadow of the planet falling on the rings behind it. Isn't that cool? And right here, actually, it's kind of hard to see, but let me see if I can show you that. It's kind of right there. You can see a little faint line right there. That faint line is actually what's called the Crepe Ring. Daryl's pointed that out too in some of our fun runs here. But there's the ring planet, and it isn't really high up in the sky, so it's suffering a little tonight. from turbulence in the atmosphere. It's really windy. It had been windy. We had 50-mile-an-hour winds last night, and we have an actual dome, as you can see in the in the view of the observatory, and that dome has withstood 65-mile-an-hour winds. So, not without help though, because it could be ripped to shreds. So I really seal up the telescope good and cover it up, and then I add other stuff to keep the dome intact. But there's Saturn. It looks pretty. I mean, it's not... We've seen it better, and it's as focused as I can get it tonight. I've been out here trying to do this already for a while.
Could you possibly do a longer exposure, see if we could catch any of the moons tonight?
Oh, yeah. That's what I'm doing now. Because it's exactly right. I wanted to show how the moon looks, the moons of Saturn look. All right, and let's go to. Let's do 10 seconds, and we'll do 10 seconds at 50 to see if we get them. And if we go to our stellarium view and we zoom in on Saturn here, all right, you'll see an image of Saturn that's just like we see in the telescope, and you'll also see where the moons are. And we got a lot of moons out there tonight of Saturn. We have Rhea, I should say, and I have to find where Titan is. Titan is usually far
Titan's
away.
over
There it
on
is.
the right.
Yeah, there's Titan. Actually, we saw it in the view earlier because it's, again, like Ganymede. It's slightly smaller than Ganymede, and it's still pretty bright. All right, so let's go take a look at how it came out. Here we go. Not long enough. You can still see Titan is right there. Kind of hard to see. So I just need to do one thing that's important, and that is I'm going to move us to... no, actually, narrowband 2 is good. I just have to take a little longer exposure, and I will up the ISO, because right now it's at 50, and we should probably take that to like 400. Let's try that.
Mark Genghis asks, what keeps the rings from slowly going away, and can a moon have rings? The rings do slowly go away.
Actually,
I
yeah.
forget, does Enceladus, is it slowly, its discharge, is it sort of contributing to the rings at all?
Well, no. Well, here's what's happening. All right. Enceladus, as it goes around Saturn, it has geysers that people know about now. The South Pole has these geysers on them. And we've noticed some really intriguing chemistry coming out of those geysers. Well, which means Enceladus is a life search target now, with Europa around Jupiter. And but as these things go around, they go up into the orbit of Enceladus. And then as Enceladus keeps going around Saturn, much of that material ends up coming back to Enceladus, because Enceladus is colliding with its previous expulsions. However, one thing that's happening with the rings is very important here. The rings will not last forever. Saturn's rings are dissipating. Yes, it's going to take millions of years for it to happen, but Saturn's rings are dissipating, and as eventually Saturn's rings will no longer be there, and it'll be a ringless planet. This was discussed in a paper that I read. I think it was last year. Might have been in Nature, or might have been the APJ, the Astrophysical Journal. I'm not sure. But it is incredible that the rings are going to be going away. It's like, who knows? In some time in the future, we will not have planets with rings in our solar system, because Saturns are the only ones that are visible. And could a moon have rings? Well, a moon can have moons. So technically, if a moon is circled by another moon and that moon collides with something, well, those particles will form a ring around that moon for some period of time. But rings are very, very hard to maintain. And a lot of physics going on that keeps them from staying forever. So moons being more tumultuous and unstable than a main planet would probably end up losing their rings over time and a shorter time frame than a big planet. Now here's why I did this like this, by the way. You'll notice that we have a moon here, we have a moon here, we have a moon here, we have a moon over here, we have a number of them, and we have Titan out here, we have another one over here. So we see 1, 2, 3, 4, 5, 6. If we go back to our stellarium really fast right here and zoom in, okay, we can see that we're seeing 1, 2, this is Dione and Tethys, okay, and then we were seeing Rhea out here, okay, and then we were seeing Enceladus, of course, out there. Were we? Maybe not.
I don't see Enceladus. Enceladus is tiny.
Yeah, it is. It's only 310 miles across, so it's not going to show up too well. But it is highly reflective. So yeah, so I guess that what's showing. And then, of course, way out here, if we just come out of here, there's a star out here, a star out there, and of course, we have Titan way out there. Okay, and you'll notice Titan actually looks a little orange. Titan is, like I said, big enough, second largest moon in the solar system, and as this larger moon, you can see its color quite easily. And what's interesting is we've looked at Pluto as well, and depending on how Pluto was relative to Charon in its orbit, we could see that Pluto had a ruddy brown color at times. So that's kind of interesting too. Pluto is even big enough. Pluto is about like this, about as big as Rhea in the telescope. It's just about like that, and it's really pretty. So yeah, there we go. So those are the moons of note that we can see. That's really kind of neat. A beautiful rendering of the moons, and I wanted to get that exposure just right because these were going to easily get knocked out by the overexposure of Saturn, so we caught it good. Very nice. Hey Rachel Sobeck is in the house. Hey Marco. Hey Greggy Gilgan, what's happening? And Genghis. I'm so happy to see you guys. And and so is Daryl, because he says hi to you guys all the time. Anahata77 is here as well. Hey Bonnie. And we are now going to just poke around in another location. I may have to move the dome a couple times tonight because it's really pretty out there, and I don't know, I just love it. You know, I want to see things. You know, just got to see things.
I had the 8-inch out the other night, last Friday night. And it was a beautiful clear night, and I dragged the 8-inch out and set it up. It was working well. A young couple rode by on their bicycles and expressed curiosity, so I invited them up and gave them an eyeful. They got to see Jupiter and its moons, and Saturn and its rings and its moons, and got to see the moon, of course, which was 5 days ago. It was waxing gibbous, but it wasn't far past first quarter.
Yeah.
And they were suitably impressed and thanked me profusely. And I was going to look at Mars that night, and darn if it didn't cloud up right when Mars rose.
Oh. Well,
but it was neat to share the view of Jupiter and Saturn and the moon at any rate.
Yeah. All right, we're going to leave Saturn behind for a little while, and we're going to run up to something known as the Little Gem Nebula. It's also called the Green Mars Nebula. I don't know where those names come from. I know it as NGC 6818, okay, which you see right up there in Stellarium's top left corner there. And what you're seeing on the screen, by the way, is we're using high precision positioning. So the screen lines up, the telescope lines up with a particular star in the neighborhood of this object, and once it lines up, it'll center it up, auto center it, and then bam, it takes off and goes to the object. And we know that it worked because we can actually see the object right here. You can't see it quite yet, but I will make sure that you do. Let's do 10 seconds at 400 right now. I should have waited a little longer. You know, after taking a run to an object, you have to wait 11 seconds exactly for the guiding system on board the telescope to latch onto a guide star. So I pushed it to the limit there. I may have missed, and it might be blurry, so we'll see. Let's find out. And what did we win? Yeah, well, look at, there it is. It worked. Look at that. I know that looks faint, and that's because we're using it under a filter, and I'm going to actually go back now and take this with a longer exposure than 10 seconds. But I'm going to take us up to 1,000 ISO sensitivity, and then we'll go, let's go to 13 seconds here. Here we go. That's what we do with SkyTour LiveStream. Every exposure we take is anywhere between 10 and 60 seconds. We don't take 1 hour exposures or 2 hour exposures, because that's actually a regular thing that astronomers do, is take exposures of that length. We don't do that. We want to make sure that you see what you get, what you came to see, and not have to wait a long time. I'm happy to wait because I'm an astronomer. I'm patient, but I can tell you that it's just the way it works. You want to make sure that people get to see things. Look at this beautiful thing. What is that thing? Well, it's blue, bluish green. Well, that bluish green is characteristic of a star that has died. And what happens is, stars, as they die, they pulsate. Okay, why? Because stars like the sun are burning. They're kind of a yellowish star, ours is right now. And it's converting hydrogen into helium in its core. The core is way down in here. The outer part of the star isn't doing any fusion. Only way down in the core is it doing fusion. All the rest of this is gas that's made so hot that it's turned into what's called plasma. That's where all the atoms lose their electrons, and all of the gas is now very, very high energy protons and electrons and so ons running around outside in the star's envelope. We call it the big gas balloon. And the core is actually doing that nuclear fusion, and when it's converting hydrogen to helium, everything is fine. The outward pressure of this radiation pushing out exactly balances the force of gravity trying to crush the star. Yoo-hoo. Well, when that does that, okay, you have a stable star. Our sun is stable. However, when the hydrogen starts to run out way down here in the core, okay, then what happens is the star begins to contract because the hydrogen fusion is shutting down a little bit. Well, as it does that, more of the stuff in this outer envelope here, this outer shell, gets pulled down into the core, giving the star new fuel that enters the core. It's like, hey, look what I got. And boom, it starts to go up again. And it keeps doing that. And that pulsation, okay, the star gets bigger and more bloated. And when a star is hot, the hottest stars are bright blue. The coolest stars are dim red. And as the star expands, the outer envelope, this outer location, gets much more cool, and it starts to turn red. And this is why we have things called red giants and red supergiants. Okay? Betelgeuse and Orion, we'll see that in a month or two. Betelgeuse and Orion is an example of a supergiant, a red supergiant. It's not red because it's always been a red star. Quite the contrary. Betelgeuse used to be an O-type star. What's that? The hottest and bluest stars that the universe has. It used to be a hot blue star, but it used up its hydrogen in just a few million years, as opposed to our sun, which has already gone for about 5 billion years, and it's going to be able to go for 5 billion more, roughly. Okay? So don't start packing yet. Well, Betelgeuse expanded into a red supergiant because it ran out of its hydrogen, started this pulsation thing, and as it got new fuel, what happened was it started to convert helium into other elements. Because if you remember the periodic table, that ugly table that you all hated in high school, in college, and for me, college and so forth, when you go look down through that table, it goes into hydrogen, goes into helium, and then you got helium that can go into lithium, beryllium, and carbon, and nitrogen, oxygen, fluorine, all the way on down. And yes, I can sing the periodic table. Don't ask me to. I won't do it unless I really, really have a lot of coaxing, and it won't be right away. Certainly not tonight. But
Good.
helium can be turned into carbon as well, and then into nitrogen and oxygen, etc. So that is where other elements come from. But that's what happens when the star starts to compress and contract, gets hotter and hotter and hotter in the core, and the 13 million Kelvin temperature that is required to start hydrogen fusion goes to 100 million to start helium into carbon fusion. Okay, and when it gets that hot, okay, that will end up causing this new fusion cycle. When that happens, the star goes whoa, and it defeats its own gravitational field, gravitational force, and expands into this massive red star, because as the outer envelope moves farther away from that core, it's getting cooler and turns redder. So you have this big giant red star. And sometimes when the stars finally go through all their fusion products, they can't fuse anything else. All right, and stars like the sun can only get to about carbon at the most. Then they start to collapse, and they have done this pulsating thing I told you about. And when they do that, they slough off these outer layers, because those outer layers get so far away from the star that there's just as much energy pushing them away as trying to pull them in, and sometimes more energy trying to push them away. So this shell makes its way away from the star and keeps going. And that's what we're seeing here. This is one of those
Tara
shells.
wants you to sing the song. I think
Nope.
Daisy and Zoe do too.
I know you do, and I'm going to make you wait on that. I won't be doing that tonight. I'll just say this. It starts off like this. Okay? There's hydrogen and helium and lithium, beryllium, carbon atoms everywhere, and nitrogen all through the air, and oxygen so you can breathe, and fluorine for your pretty teeth, and it goes on and on and on, and I'm not going to do it tonight.
What tune is that to?
Can.
Oh, okay.
So that's what happens here. The star has been sloughing off its outer layers as it dies, as it finally does that final contraction. And what's it finally contracting into? A white dwarf. That's what's in the core of this object right here. A white dwarf. Yep. And the white dwarf is 45 to 50,000 Kelvin. And that's the temperature scale. And if you look at how the Kelvin scale works, it gives us the ability to have an absolute zero. Okay, so 0 Kelvin is minus 273 Celsius, which is minus 451 Fahrenheit, something like that. And it's what we call absolute zero. It gives us a zero scale, and it just goes up. Okay, just a different way to talk temperature. Well, anyway, when we look at stars and their final death throes, this material here that's been pushed off and sloughed off, these are concentric shells in some cases. Sometimes they go off in odd ways, like lobes. Okay, those are called bipolar nebulae. Okay, the Dumbbell Nebula that we've seen is one example. And so might be the Ring Nebula, but it looks like a sphere to me. I take issue with the people that say it's not. But anyway, this object here is also in this turquoise color, this beautiful bluish green. And that bluish green is something Daryl's familiar with and I'm familiar with. And it's a particular element in the periodic table. And do any of you know it? I know, Daryl, you know what it is, right?
Sure.
Yeah. Okay.
Doubly ionized oxygen.
Doubly ionized oxygen. He's exactly right.
Slipped there for a second.
No, that's okay. You know what? It's easy to do because of the way the nomenclature we use. So this blue is a particular color for a particular element in the periodic table. Why do we have a particular color of anything? Well, because most of the envelope of the star, at the point that it died, at the point that it came off of the star, most of that envelope of gas was a particular element, or a predominantly same element. And in this case, it was oxygen, because oxygen was one of those products that it was, one, made up with when the star was first created, or two, is material that was down near the core that got dredged up in the final death throes of the star. And that's actually called a very, very scientific term. It's called the dredging up process. Who knew? It's the dredge up process. And there's several of them in a lifetime of a star. So we watch this process here. We see this oxygen right here. Now, it's not just blue, and it's not just this bluish green. It's also got other things going on there. You can find some hydrogen in there. And why is it glowing? It's glowing because of the fact that when we look at this, let me see if I can get it a little closer. There we go. Yeah, we'll take a better photograph of it. When we look at this thing, and we look at the color, okay, one of the things that we're seeing here is you can see a little, it kind of has a little hint of a reddish tinge around the outside, and that could be neon, okay, and that could be hydrogen gas that's being forced to glow, because the white dwarf in the center is very hot. Most of its radiation of that white dwarf, that final core of a star that's left over, that's cooling, finally it'll become a black dwarf eventually when it cools to 0 Kelvin. It's only about a little bigger than the Earth in size, and you can see white dwarfs from many, many light years away. You know, we see them all the time in some of these planetary nebulae. We'll probably see this one if we do a longer exposure. The fact is, when we do this, these objects are just, I guess you might say, a very, very slow way for a star to die. You know? And we've seen some very fast ways that stars die. And we've actually imaged them here. And those of you that know me know that I actually have spent a lot of time looking at objects that stars that blew up, supernovae, and I'm telling you, they are just incredible. You know, it's a star that explodes its guts to the interstellar medium. As bad as that sounds, okay. Yeah, this I tried to go a little long, and I have a little. I can see that I have a little. I think I'm getting the edge of the dome in the view right now. Yeah, I can. Well, yeah, we are. And I have a red light on in the dome, so that lets me know when we actually have a problem. And we have something getting in the way. So if I come back here, I will show you the dome cam, and you'll actually see down here. Okay, look over there. You can see that the edge of the telescope is actually intersecting with this part of the dome a little bit. See that? Telescope's hitting that. Well, that's bathed in a red light. And that's how I know we have a problem with the dome. Now in Arizona, again, our observatory is being built now as we speak. I'll be out there at the end of the month into November, probably for 2 full weeks, getting this all live, taking the telescope you see right there to Arizona and installing it in the new building. And we're gonna be live at the end of I'd like to say the end of this month, or no, end of October. But we'll see. You know, we'll see. Very exciting, because we're gonna have a 12 by 12 building out there with 3 different piers, locations within the building to put telescopes, and those telescopes will be this one, and then I have another streaming group that's going to be taking another pier. They've already purchased that, and then we're also going to have a third setup, because we're looking forward to possibly adding another astrograph to our telescope lineup there. But that's possible. I'm not saying that it'll happen, but I might just decide to go to a wide field system too. That's not an astrograph, you know. Now let's take a look at another nebula. These are called planetary nebula, by the way. And Daryl, if you've got some objects you want to check out, feel free to just cut me off and tell me what you want to see.
Okay. Genghis was asking about clusters. I
Okay.
know clusters are always a good choice on a moonlit night.
I know. All right. Well, you name me a cluster, and we'll go check it out, Daryl.
Golly. I
Yeah.
don't know.
Oh.
Let me think about it.
All right. While you're thinking about it, I'm going to show folks the Saturn Nebula.
We have a globular cluster there just to the lower right of Saturn Nebula, M72 Globular.
Okay, we'll check that out. So our telescope looks like we're just barely clean of the dome. We'll do 13 seconds is going to be too much for the Saturn Nebula. It's really actually compact and somewhat bright. So I'll take us down to 3200 ISO. Okay, and go let's do 8 seconds at 3200. Check that out. Maybe it worked, maybe it didn't. Hi, Do. And Do, your question is Venus to the south. Where is it?
We just answered it.
Okay, thank you.
Tara, what's an astrograph? Mark might embellish on this, but an astrograph is usually considered to be a telescope that is dedicated to imaging. They tend to be lower F number, wider field.
He said it all, Tara. He said it all. That's true. Okay, I might have to explicitly select. All right, let's go see whether it's showing up. I might have actually yeah, I think I gave you the wrong thing. My apologies. I shall now go back in and do this again. So, Saturn Nebula is right there. Now we'll go there. All right. All right, so here's our star. Let's bring in a bright star. And then it's going to... And again, that scope icon is in the wrong place. I'm working on that. And there's the Saturn Nebula. You can't miss it. It's another beautiful object. And we should be able to look at that without any issue here in just a moment. Now I gotta wait the 11 seconds for the telescope to catch a guide star. You'll notice in the observatory view over here, you can actually see the telescope is looking right out of the middle of the slit. That's good. All right, we have our guide star set up now, and I'm going to go over to our camera setup, and let's see, 13 seconds at 10,000 is probably too much. Like I said, we're gonna go to 3200, and we'll go 10 seconds, and that'll be too much. So we're gonna go down to say 6 seconds, and that might be okay. Maybe not quite. Not quite. Let's go see. So this is another one of those planetary nebulae, and there it is. And you can see why it's called the Saturn Nebula. This is important because we just saw Saturn, didn't we? And now we see it again, didn't we? But it's this little nebula now. You know, it's so cool looking. You can see this little blue. And again, we're looking at the same elements that we talked about before. This is doubly ionized oxygen. Now, when you look at what doubly ionized oxygen is, okay, doubly ionized oxygen is actually, its nomenclature is O for oxygen and then Roman numeral 3. But wait, it's doubly ionized, so why isn't it 2? Because O1 is just the atom with all of its electrons. Ionization is when you throw so much energy into an atom that one of the electrons bounces away and goes up and off the atom. That's called ionization. And if you ionize it once, that's O2, because O1 is where all the electrons are there. See, we love to fool you. We love to give you all kinds of these these acronyms and science just makes your life so difficult. Sorry, but that's what happens. So this is the Saturn Nebula. You can notice this beautiful little rim right along the middle here. That's really pretty. Let's actually go back now, and maybe what we can do is just take a picture, an image that's a little less. Let's dare to go down to 50 ISO. Okay, so really, really, really low ISO. Okay, and now let's do a 13-second exposure and see if this gives us the right combination to show some detail in this planetary nebula. Oh, I'm so excited. So let's go back over there and wait. So we should come right in here. Oh, not quite enough. Notice it's not quite enough. It's right there. So I'm going to go back. I am on the narrowband 2. I'm on the wider narrowband filter. So what I'm going to do is just pump this up from 50. Let's go to say 100, and take this and go to 25 seconds. Okay, now let's do it again. Yeah, Daryl, I can't wait to look at Mars tonight. Can you?
Keeping my fingers crossed.
Yeah, I'm looking forward to it. We're going to look at it. Mars looks beautiful, and we saw it the other night, Daryl and I, and all of you. And the next to the last night we saw it wasn't so impressive, but the night before that, it was very impressive. Very impressive. Okay, here is, this view is a little bit more, it speaks to more of what I was talking about before. You can see this beautiful outline. Okay, and you'll notice it's oval shape. And if a star has got these concentric shells of material coming off, then why is it doing this? Why is it oval shape? It doesn't make any sense. The reason it's oval shape has to do with the fact that the star might have been a rapid rotating star, and more materials coming out at the equator side than at the poles, at the top and bottom here. So it's possible that the equatorial spin is what made this thing do what we see here. All right. And it really is quite elaborate. There's another faint feature which I don't think you can really see too well, but you can now. You notice this has a halo of blue around it here. This is really interesting because that shows us that there's more detail going on, and more shell material that has come off previously. That's the previous shell. The most recent shell will be the one that's inside, actually way near the inside. And if there's a shell in there, then that would be it. So we can go just a little brighter on this, I think, and maybe increase the ISO by 3 stops, go to 200 ISO. And let's do that for 25 seconds.
I have a question.
Of course, sir.
This is the Saturn Nebula, correct?
Yes, it is.
Is that the same as the Ghost of Saturn Nebula?
Oh, I don't think so. But
Okay.
I could be wrong. I could be wrong about that. That's one for you to look up.
Yeah. Famous last words.
Yeah, right?
The neighbor who had a
this is
10-inch
beautiful.
mead, he captured the Ghost of Saturn in his scope one night. It was really something to see.
Look at this, Daryl.
And you could see details in it, yeah.
Look at this.
I see a bright spot there in the center part, a little to the upper right of center.
Oh, you're talking about here?
Yes.
Yeah. Yeah. And notice this fringe. Look at this fringe going around here. This is so cool. Look at that fringe. That's such a cool fringe. And that actually, if you notice it actually it's red. It's a little bit more red. So here is probably an example of, say, hydrogen in here and some oxygen, the O3. Now the O3 is a real dominant color, so we'll see that over some of the other colors. But look at this. Isn't that beautiful? You see the core, and you see some other mottled detail in there, and then you see this outer shell with intricate detail all throughout this fringe. You see, it could just be a blue thing in a telescope eyepiece, but if you can tune the camera, take a just short exposure, a little longer, a little short, a little longer, look what you can dig out, look what you can pull out. And you know, Daryl is a traditional astronomer in regard to, he has to see it with his eye. I totally respect that, because I've always been that guy as well. But I guess you could say that I've been bitten by the bug to make sure that I can capture the most exquisite images of these objects. And this is doing it with the camera. You could take a picture of it through a telescope too, with just a regular camera. But let me tell you, this is really pretty. I'm seeing detail in here that would have been elusive. It's almost like it's radial spikes sticking out. You see that, Daryl?
I'm sorry, I was looking it up. Say that again.
Yeah, no. It almost looks like there's like spikes coming out, like radially from this. You know.
I see what you're saying. Yes.
I don't know if that's what's really going on there, but man, that's something. Really.
Well,
something.
I did a search for Ghost of Saturn Nebula, and everything comes back to Saturn Nebula, so maybe they are the same.
All right, cool. Very cool. I love it. I'm going to take us to 400, because that model detail might be lost, but I'll leave it at 25 seconds. But I'm going to see if we can get our model detail. So right in this very spot, you're going to see it'll be shifted a little tiny bit, but you'll actually see it again. I may have to get out of the way here because it may move. So I'm going to move down until we see it again. So we're going to be right there. It's so exciting. And what's it going to look like? Oh, look at that.
I may have been thinking of the Ghost of Jupiter planetary.
Ghost of Jupiter is definitely a planetary, yeah.
Yeah.
Look at this. Again, we see the detail here. Now, look at this area, Daryl, that you were talking about before.
Yeah.
We're seeing like a dull area, a darker area. So there's modeling going on inside this nebula. And then there's some actual, you see those, look at that sharp-edged ring right there, that sharp edge to it. Okay, that is a shell that has been thrown off of this star that's buried in the center of this. And what happens is, at the edges, if you look at my hands, when you're looking at the from front to back, okay, you can see through my fingers. But if I turn to the side, you can't see through my fingers. Okay, well that's how come the shells look so thick on the edges. All right, now through the center here, we're seeing a lot of stuff anyway. Okay, but on the edges for these gossamer shells, the edge looks very thick because of the fact that it's actually got this illusion going on because of the density thing on the edges versus straight across, straight on. Just a beautiful shot. That's really nice. Wow. Oof. So yeah, so that's Ghost of Saturn, or the Saturn Nebula, and it is. We took this picture with the nearly full moon. So obviously these filters look really, really good. You know, they work really well. And not too far away now is Messier 72, which is the Globular Cluster. And right next to it is another cluster. So we can actually go to that little cluster first. Why don't we do that? This little cluster is M73. And this globular cluster here is M72. So when Charles Messier in the 1700s was putting together his Messier catalog of objects to avoid if you're hunting for comets, he saw this one first, and then he saw this one. Stands to reason it's fainter and dimmer than M72. So I think that's pretty cool. Okay, actually M72 is fainter overall, but this one here is the one that he saw second. So let's go check this out, shall we? We're going to head there from the Saturn Nebula. I can actually probably just go down a little and over, but until I get the crosshair thing, the scope worked out, I can't actually do that and make it work too well. So, all right. So here is our guide star we're going to, and you can see where the telescope is over here in the dome. And then we're going to this little cluster, Messier 72, or 73 rather. Yeah. Yes, sirree. Now we're waiting for our telescope to catch its guide star, which is going to happen in just a few seconds. We'll be there in a second. All right. Incidentally, for those of you who've been here with us before, this system over here is going to eventually be playing a bigger role in what we do. I've already used it directly to control everything with the telescope, and it works very well. There's a few little glitches, and there's someone who's written the software driver for our camera, and we're working out the details, but we can do a number of really good things with that new process. So let's go here. Let's go and say, hey, let's go up to a standard, we'll go to a standard 8,000, and we'll say 25 seconds. We have our guide star, so let's go. Let's see what happens. Yeah. So we're looking here. This red square represents the field of view of our telescope, by the way. That's just so you know, I set that up specifically for this particular telescope. Okay. Now we come back and let's find out if we have it. There it is. Look at that. Look at that little cluster right there. Isn't that something else? That little guy. Right there. It's like UFOs flying over my head. Hi. You know? That's really cool. Just that there's a number of these little tiny clusters. Now, what are these clusters? What's interesting about these clusters is that they formed when there was a lot of hydrogen gas in a particular localized region of space. And that hydrogen gas promoted star formation, because as this hydrogen gas cloud started to segregate off and get knotty and clumpy, okay, some of these clumps would compress into objects that became stars. The rest ended up getting blown away by the new stars that formed there. And this could be very small, and this could be very large, gas clouds. In this case, it might have been a very small gas cloud, but look at that. These little lonely stars sitting off there in the distance. Yes, I'm a bit of a romantic when it comes to astronomy. But you know what? I think that everybody should be. It should touch everybody the same way. You know, it's just an amazing, miraculous science. You know? So, and those stars are 2,511 light years away, incidentally. 2,511 light years. Okay. Now, if we actually go and move over now, we should probably be able to get to Messier 72. So let's go find Messier 72, and then you'll see what a cluster of stars looks like on steroids, because Messier 72 will be one of these guys that has a lot more stars. It's also a lot further away. So let's go there. You know, in the springtime, we look at in Hercules and we see Messier 13, which is a globular cluster. And Messier 13 is a very, very bright globular cluster. You can see it in individual stars quite easily. And Daryl tells you about seeing something called the propeller, which is the apparent void of stars in a certain way that makes it the cluster look like it has a three-bladed propeller kind of in it. I don't know if there's Any other features for other globular clusters, Daryl? Do you like that?
I don't recall offhand.
Okay.
I know if you start looking at M13 and you stare at it long enough, you'll start seeing other dark lanes in the cluster.
Oh, yeah?
And I wouldn't be surprised if you would see the same thing in other globular clusters.
Okay.
I think M22 might have some.
Measure 22 is down in Sagittarius for you folks listening. It's a very big globular cluster, but not the biggest and the brightest. The one that I've not seen that Daryl has. I'll tell folks about that one, Daryl.
Omega Centauri.
Yes.
It is way down in the southern sky.
Well, not way down. We'll see it in Arizona. We'll be able to see it.
It just barely breaks the southern horizon here in Colorado, and it is not resolvable from here.
Okay.
I've told the story before. I saw it when I was down near the Mexican border in southern New Mexico back in '94, I guess it was, and I went down there to see the annular eclipse from El Paso. It was about 8 to 10 degrees above the horizon. It was resolvable from there, and it was nearly as big as the moon in the sky. And that's naked eye. And in the telescope, it was amazing. I forget how many, like 4 million stars in a globular cluster.
Isn't that amazing, guys?
It was just huge, and it was beautiful.
To give you an idea of how big that is, the full moon takes up this entire size right here, top to bottom. This is about the size of the full moon frame right here. Okay, and equally just about as much. Okay, a little less. Well, this globular cluster we're looking at here is only going to be the size of one of the bigger craters on the moon. Okay, relatively, superimposing. What Daryl's telling you is that Omega Centauri is the size of this entire frame. Can you imagine that?
It's such a rich sight. It was amazing to see.
I guess you could watch that all night long.
We spent a long time on it. I know that.
Yeah. Hey there, Codus99. How you doing? Yeah, that's just amazing. And this one here, we're just barely picking up. But again, I'm using a filter. And we could go a little higher. Let's try 3 stops here, 4 stops, and I'll go to 30 seconds. So each of these numbers that go up is a stop, it's called. And that indicates that you're taking you're adding another percentage of light to the sensor, whether you go up in the sensitivity or the exposure. If you can do it by going up in the exposure, that's better, because going up in the sensitivity adds noise. The higher that ISO that you can see over here that I showed you before, the higher the ISO, the more noise gets in there, the more granular, the more specular little dots appear all throughout your image. And we're trying to avoid that.
May I answer Tara's question?
Please do, yes.
Tara, these clusters are inside our galaxy, so they're staying in our galaxy. They're not flowing anywhere. They are, of course, revolving around the center of the galaxy, along with everything else. What moves toward the Great Attractor is other galaxies, other clusters of galaxies. The Great Attractor is thought to be a supercluster of its own, far down in the southern sky, Triangulum Australia, I believe, and another constellation, I don't remember its name, but it's the Carpenter's Square, far down in the southern sky.
Oh, yeah.
Huh?
Yeah, no, I'm sorry. I didn't mean to. I was trying. I thought I knew what that was. I'm trying to remember. We'll go
anyway, everything in our local part of the universe is flowing toward the Great Attractor, including the Virgo supercluster in Virgo. We in the Milky Way and all the galaxies in the local group, our local bunch of galaxies, are all falling toward the Virgo supercluster. But the Virgo supercluster is falling toward the Great Attractor, way down in the southern sky.
this is the guy you're talking about, right? What the heck? Oh, I totally get rid of the ground. If I turn off the ground, I should be able to see a tree. Let me just click on that. Yeah, Triangulum Australia. Right there.
Yeah.
There it is. Yep.
And then the Carpenter Square is somewhere next to that. That's probably just to its upper right.
Here?
Yeah.
Okay, and that is this right here.
That looks like a Carpenter Square.
Indeed.
Norma? I forget. I'd have to look that up.
Yeah, Norma.
It is Norma?
It is Norma. Yep.
Okay, yeah.
See, folks, we get you all the answers. Even if, I don't have all the answers for constellations and mythology like this, Daryl could certainly tell you more about that many times, because I'm not that guy many times. I'm actually more of a, I'll tell you about a planetary nebulae, but if you want to talk about, some of these other things and seeing objects for the first time, Daryl has some stories which will rivet your attention about people when Daryl used to do this stuff. He used to do public outreach stuff like we do here, like I do. I've always done that as part of my job as well. And it's just so interesting to be able to spend time telling people about things that are in the night sky that they didn't even know were there. And then you show it to them. Oh. Mm-hmm.
I could add a little to that.
Please do.
When you look down, far down in the southern sky, those objects, those constellations, were named relatively recently, like late 1700s and forward from there, in the so-called Age of Reason. So instead of being named after mythological figures, they're often named after man-made instruments and stuff like that. There are some animals down there and parts of ships, but a lot of the objects in the south, you'll see things like Fornax the Furnace, and Triangulum Australia, and Norma, the Carpenter Square.
Whereas up here, we see things that are related many times to mythology.
Yep.
Awesome stuff. Now, I have a better globular cluster for you guys. Okay, this is measure 2. And it's right here, so I'm going to make sure that you can see it. Okay. If you're eagle eyes, you can actually see it moving across the screen there, but okay, here we go. Now we're gonna wait 11 seconds, let it catch up, and then take our exposure. We're going to go down 12,800, 25 seconds for at 12,800. Let's go see. That's not it. That's the old one. There we go. Now, see, that's more of a globular cluster.
Nice.
Is measure 2. You'll notice the blue. This blue is, of course, because of the moon. A nearly full moon. We're a day away from full moon, and the sky's going to have a blue cast. But don't forget, we're using a filter that is that wider band cut through the main spectrum. If we go now and go to the let's do this. Let's go to the other filter. See, this says down here, right there, it says narrowband 2. See it right there? We're going to change that now to a narrowband 1. Right? And now our sky is going to be dark purple, almost black. Okay? And this will be better. So I'm going to go and I'll go up, I'll stop 16,000 and 25 seconds again. And now we'll see the difference between the filters. I used this filter and I was able to see the Eagle Nebula, gorgeous. Now, this filter pulls in specific wavelengths. It's a very narrow slot filter through these different wavelengths. That's something that is very important to notice. So, when we do this, okay, you'll see that this is looking a lot darker, right? And we see there's a little more, it looks a little like a little more noise. Okay, you see this? This is the noise I was talking about. But then again, remember, we are at 16,000 ISO right here. And we're going to drop that down. This camera goes from 50 to 409,000 ISO. We're going to do 5,000 and we're going to just for fun, let's try it at 1 minute. Okay? So, let's do that. The other night I was doing exposures of like 1 minute, 2 minute, 3 minute. For me, I was taking some photos. And they were coming out really pretty. But not necessarily have to do that. When I have you guys tagging along, I don't want to make you wait all this time for exposures to show up. You know, because that's, you know, that's no fun. You want to see stuff. You know, incidentally, if any of you have any objects that you'd like to see, let me know. And if they're up, we will check it out. Okay? And that's for those of you that, you know, that know some astronomy. If you don't know some astronomy, don't sit back and just not ask questions. Feel free. There are no stupid questions. Trust me, I've asked them all. I promise. When I was getting my astronomy degree, I asked questions that were embarrassing, you know, to the professors. I was like, oh gosh, I can't believe he's asking that question. I told him to answer this question. But I'm like, yeah, but I don't understand. I need more help. And then he would say, okay, let me explain again what half-width is. And we went through, you know. But the bottom line is, there are no stupid questions. None. All right, so we are taking our 1 minute exposure still. All right, and we come back. This is the old one. And we'll see how the 1 minute fares. The 1 minute, if the guiding is good, if the telescope guiding has been tuned right, then we should be able to see just fine. And it should work out. The stars will still be round dots. If they're all dragged out, it means it got poor guiding. Sometimes that happens because the dome gets in the way. And that's no fun, that's not exciting, that's terrible. But sometimes the dome gets in the way. And at this angle in the sky, there's a handle on the shutter that sticks down that you close the whole dome with. And that can get in the way of the guide scope. That's why I'm getting rid of this dome. I have one dome up on the Facebook Marketplace right now, a fiberglass 8-foot dome. 6 foot. Yeah, see? It did that. So what that's telling me is that that little handle that I was just telling you about, the thing to close, has gotten in the way. Because the main telescope is here, and then above it you have another guide scope, and above that you have another tiny little scope. And the two of them have to talk to each other to get that thing lined up to keep it guiding. But if that little tiny scope is blocked by this handle, okay, then all bets are off. And we are now seeing the result of all bets being off. All right. So, unfortunately, then that means that I will either have to move the dome or just deal with it. Oddly enough, you know, we can actually go to different places. I'm thinking I'm gonna have to go move the dome now, Daryl, because you know Mars right now is about 28 degrees above the horizon, 28 and a half. So it's not really that good right now. So we have a ways to go, but maybe we can go view, with the moon right nearby, maybe we can go view the Triangulum Galaxy and the Andromeda Galaxy.
Sure.
You know, and then when Mars is better, we'll go view that. So I'll go move the dome. Can you keep everybody entertained?
I will try.
Yeah, like you have a problem with that. You're really good at this, Daryl, and you know it. I'll be right back, guys.
Hurry back. Oh golly, what could we talk about tonight? I'm not going to sing. I poo-pooed Mark singing, so I shouldn't sing either. The shadow of Callisto is well onto the face of Jupiter now, but I suspect from Mark's point of view, Jupiter is so far in the southwest that he probably couldn't catch it now. If so, it'd be a really degraded view and we might not see it anyway. But, so it goes. Let me check here. Crack some eggs of wisdom on our brains. Oh golly, I don't know. I need a little help. I need to make an association. Throw something at me and I'll see what I can do for you. It's been a long day for me. I woke up before 5 o'clock this morning. I did take a nap, but still I'm running on a sleep deficit here. I thought about taking the scope out again last night. It was what about the Election Day asteroid? I'm not really up on that, Vera. I've heard about it, but I haven't bothered looking up. I think it's actually a pretty minor asteroid, more like a space rock. Yesterday was a beautiful day here, sunny, upper 70s, and it was a beautiful clear night last night. What's my fascination with Mars? Oh, it's when it's close, it's big and it's bright and it's red and it shows lots of surface detail, or can, Genghis. A lot of my fascination with Mars probably goes back to when I was in my early teens. My twin brother and I cut our teeth on the Edgar Rice Burroughs novels, including all the the John Carter of Mars novels. They made a movie of that some years ago. He wrote a ton of books about Mars. They were very romantic and sword and sorcery and all that kind of thing. And we cut our teeth on that stuff, and fun times. Mars has always held a special fascination for people, just because of the way it behaves. It comes around every 2 years or so, and it'll get big and bright in the sky, and it's the god of war, Ares. It's always held a certain place for people, and I guess it holds a place for me.
Mars is a very interesting planet anyway. We look at Mars and think about it as a potential place for humans. Mm-hmm. We look at Mars as a potential location from where panspermia may have originated. For us, Mars had lots of water at one point, and it still does. It's just locked up in the crust, and some of it's escaped to space, right?
Mm-hmm.
And knowing that, we also know that Mars has had a very special relationship with asteroids and comets, and has actually been pelted by them in the past. So every impact on Mars could have blown a large amount, and has blown a large amount of stuff off of Mars. And it might take millions of years for it to reach us, if it does at all. So we know there's many meteorites that strike the Earth that may come from Mars.
This is true. There are some. They're among the rarest of meteorites, but they have identified little pieces of Mars here on Earth. There are sugartites, knocklights, and shastagnites, I think they're called. And if you're ever lucky enough to find a Martian meteorite, they are literally priceless. And you can write your own meal ticket with that.
Well, you only have to go to Antarctica to get those.
Oh, not necessarily. Antarctica helps nowadays. That the one that came out back in the 90s, ALH 84001 or whatever it was called.
Yeah.
That's the one they thought they found Martian bacteria inside the rock.
Okay. Yeah,
it was discovered in Antarctica. It's one of those where the meteorite landed on the ice, and it came moving in the river of ice, and the winds evidently blasted the ice off of it, so it was exposed, and they found it laying on the surface. That meteorite, that was the one I told the story before. I was off on my annual summer camping trip at the time and had been out of touch. This was before the internet, and I did a public program one night, and everybody started talking about the Martian meteorite and possible discovery of life inside it. And I hadn't a clue what they were talking about because I had been out of touch all week. But they have backed off on that claim since.
They have.
Somewhat, at least. I mean, the jury's out, I guess you would say.
Yeah, I think it still is. But, you remember we did the entire SkyTour radio show on that for, an hour, I guess. We talked about the Martian meteorite and the prospects of life and why the Martian meteorite was so impressive and so interesting. There's a lot of things that were found on other planets that can't form there, can't form without the presence of water, and that's something that's very important. And we see that here too. We know that Martian meteorites contain compounds and things that couldn't have formed without the presence of water. So that gave us the early clues that maybe Mars had lots of water on it, or had in the past, and it certainly has. And it's just an amazing it's an amazing planet for that. And we know that Mars has been one of these planets that has, throughout the years, been subject to incredible bombardments and so forth. So I think that the prospects of Mars having been a place that might have fostered life on Earth at some point and in some way might actually be something that is worth delving into. I just think that's a possibility.
There's been some stories out just recently about maybe new discoveries or thoughts that they have found subterranean lakes on Mars.
Actually, that's actually a finding that was true. There's around under the South Pole. Actually, they found a multi-kilometer long lake that's just about a kilometer below the surface of water, liquid water, and it's probably highly saline. Okay, which doesn't mean anything. I mean, there are creatures living in the brine at the bottom of our ocean, which is another interesting discussion to have. But interestingly, when you look at the Martian surface and you look at the Martian environment, you don't think of it as being a place where there might be life. You just don't. But if you consider that below the surface, below the radiation penetration level, that is where ultraviolet radiation from the sun can get down and sterilize the soils on the top, it can't get down deep below. So there might be an ecosystem that started down there millions of years ago. And there might be microbial life. Now, why do we think that could be possible? Why would we even entertain that thought? The reason is because here on Earth, we've seen that very same thing. There's a lake in Antarctica. Who knows the name of the lake? I think you might know it, Daryl.
I forget offhand. I bet it's Russian, though.
It is. It's Lake Vostok.
Yes, Lake Vostok.
Lake Vostok is in Antarctica, and it's a lake that exists a couple miles beneath the Antarctic ice. It hasn't seen the light of day for many, many millennia. Okay? And so what's happened is the creatures in the lake have formed their own recycling system, their own perpetuation of life. The cycle of life continues there, and it's based on chemosynthesis, chemical synthesis, as opposed to photosynthesis from light, from the sun. So that process in Lake Vostok has given rise to over 3,500 different life forms down in that lake in the forever dark. So why would we not think that there could be a possibility that there could be life elsewhere that might rely on the same thing? And we see the variety of life that we have here, and why couldn't it be elsewhere? So maybe Mars, with a lake deep beneath the Martian South Pole, Lake Vostok is kind of cold, guys. It's pretty cold down there. But the lake is not frozen. Why? It's not frozen because it's under such pressure. Under pressure, you can keep the water from freezing. And the salt content, if there's any, will also... It's a freshwater lake, though, but the salt content, if any, can keep the temperature, the freezing temperature down as well. So it's a very interesting lake and a very interesting location, a very interesting possibility, because that's what gives us all the excitement about the Martian water. Maybe we'll have a lake under Mars that has life in it, and not just be a lake. It might actually be life there. Is that not incredible? I think it's really cool.
Sure.
Yeah. All right, let me see here. I'm bringing the Andromeda Galaxy into the view a little better here.
I remember reading somewhere, apropos of nothing, that one of the Martian meteorites, a Knocklite, I believe, Nakhlites, killed a dog. It struck a dog and killed it dead. I want to say it was in Egypt, somewhere like that, over in the Middle East. I think Egypt.
Wow. That's one unlucky dog.
Yeah. Vera asked, how do you know it was from Mars? I assume she was talking ALH 84001.
Yeah. I was alluding to it before, Vera. Excellent question, by the way. When we see rocks that strike the Earth, we can tell by their composition where they come from. Because Mars formed in a certain way, and other asteroids and other objects formed in certain ways. So we can tell where they come from. Now, it really does help that we're on Mars and have been for quite a long time. And so with that said, we've been going to Mars for decades and decades. And with our science laboratories on Mars, in fact, one, Mars Science Laboratory is one of them. Curiosity rover is the most complete science package ever delivered to Mars. Perseverance will be as well once it gets there with the little tiny drone, the Ingenuity drone. But once we see what the composition of Mars looks like, we know what their rocks look like, and when those rocks show up here on our Antarctic soil or on Antarctic ice, then it's a direct comparison. Say, wow, except for the influence of ultraviolet radiation and the breakdown caused by ultraviolet radiation that we know, This rock is indeed a Martian rock. It's identical. So we can do those direct comparisons now. We couldn't say, well, this rock comes from Pluto, or this stuff comes from Pluto, with any true degree of certainty. For instance, we do have lunar meteorites here on the Earth, meteorites that struck us from the moon. How could that happen? Again, a large object hits the moon, blasts stuff off. Some of that stuff comes back down to the lunar surface, but some gets away and ends up circling the Earth probably for years and years and years, and then finally it re-enters the Earth's atmosphere and boom, it hits the Earth at some point. That has happened as well.
Those are priceless meteorites also.
I know. I want one of these priceless meteorites.
Hey.
Me and everybody else.
I got to see a moon rock once. The local Air Force base has a little tiny museum on base, and they actually had managed to obtain, I'm sure it was just a loan, not a permanent thing, but they had a little tiny moon rock from one of the Apollo missions on display there. And the display it was built into was like nuclear bomb proof. You couldn't touch it, period. But B, if you did try to, I think it was like burglar proof. You couldn't crack the thing to get into it and steal it.
Yeah.
But that's not to say that there have not been lunar samples stolen.
Mm-hmm.
Because there have been.
Yeah. Well, all the moon rocks are in a place called the Lunar Samples Vault, and it's at Johnson Space Center. And it's actually called the Lunar Sample Laboratory Facility. And the only way you touch these moon rocks, and it's in Houston, the only way you touch these moon rocks is to go through these glove boxes. And, you put your hands in. You don't actually physically touch them. You touch them through these special gloves that are attached to these glove cabinets. And what they do there all day long is they curate the samples. They take certain samples. They cut slices off to send to laboratories. They send chunks to other places, to universities for study. They do loans, which is what you're talking about. And these are just amazing. It's amazing to be able to do that. And the thing is, if you're an accredited facility, you don't have to really pay for these moon rocks because you already did. You paid for the mission to get them. Taxpayer dollars. So it gives you an opportunity to actually get a moon rock and just look at it and be able to look at it. But it's a very, very tightly managed process. So
didn't somebody, I don't know if you'd say they stole them, but somebody not authorized or whatever got their hands on a few lunar samples some years ago. I think they got in a lot of trouble for it when they finally caught them.
Yeah, I mean, it's like stealing the Hope Diamond, except it's more valuable than the Hope Diamond. So I think that's probably the part of the allure for thieves. But you know what? Good luck breaking into the Lunar Samples Vault. I saw what it takes to get in there, and it's just, the security is unbelievable. You think getting on a plane is hard? You think getting into a top secret facility is hard? I got news for you. The Lunar Samples Vault is even more tightly secured. This is the Andromeda Galaxy, and this is with the moon out, and we're also looking at it with this special filter, the narrowband filter, the very tight narrowband filter. You can see part of the dark lane over here in the galaxy. You can see a little more over here. You move it up and down, actually, or in and out, you can actually see a little better. You can actually see as you move it, you can see there's something here, something there. Now what I'll do is, if we'll go back here for just a second, we'll go back to our other view. And here's the lunar, I was trying to show you this too. This is the Lunar Samples Vault right here. Lunar Samples Vault, Houston, Texas. All right, courtesy of Dome Cam. All right. So Terry Groff, you live in Dallas. Get yourself over to Houston and get yourself some moon rocks. Let us know how you do. Okay, here's what we're going to do. We're going to go over here and we're going to bring up our control wheel right there, filter wheel, and we're going to change to narrowband number 2. And the field will be considerably bluer because the Andromeda Galaxy is somewhat close to the full moon. Not really, but still a few degrees away. And we're going to take a picture now, 30 seconds at 25,600, and see how it looks. And then we'll do the same for Messier 33 and Triangulum, which is a fainter galaxy, but we'll take it with the special filter as well, and then the other one just to see what we get. It looks like it'll be pretty cool. If we go look at the full moon, you won't see any detail. You're gonna say, "Oh man, it looks terrible," because there's no shadow contrast. It's almost full. It's not quite, but there it is. Look at that. So here is. Let me just do this. Okay, I rotated it so you get the full picture. So there is the Andromeda Galaxy. Now you can see a little better. All right, and that's with the full moon. You can still see some dark lanes in here, even though it's got the full moon out, a nearly full moon. That's pretty impressive. This is with the other filter too. So these narrowband filters, again, they literally get rid of most of the stuff you don't want. And that's very helpful, you know. So let's see here if we can go while we're here as well.
Mark, would you excuse me for a moment, please?
You will be back shortly. I got you. Go right ahead.
I'll be right back.
No worries. Let's look at NGC 752. We're going to check it out and see if we can go there. You'll see there's not a whole lot of bright stars in the area, but you normally would see a star whipping through the field as we go. We're going to be going to a star that is going to act as a guide star that will take us to our location, but only if the telescope can see it, because if you notice, the telescope is looking at a fairly steep angle. What's on the other side is the guide telescope. There it goes. Now it's heading up to where it thinks it's going. Well, and we're going to see what happens here in a minute. Hey, what was that? Where'd you go? Okay, let's just go see what we looked at there. I think we probably went zipping by some of these stars. Okay, so let's see if we caught it. Our guide star might have been, or our alignment might have been, not alignment, but our pointing accuracy might have been compromised if this is being obstructed by the dome. Again, that's the reason I'm getting rid of the dome. I can't. I mean, it's really cool to have a dome on your front lawn, let me tell you. And yes, it's on my front lawn. There's a second one on the front lawn too, and that one's actually listed on the Facebook Marketplace for $450. So people can actually buy it, and they can turn it into a giant composter, or they can use it to put on a building and have a telescope inside. It just needs some rehabbing. That's why it's only $450. It's all fiberglass too, made to go over an 8-foot building. So it has to be fixed. These would go for easily $2,500. You know, okay. I think that's the cluster up there, just off the view. Yeah, it's hard for it to point when it has trouble with the dome and it's obstructed. Okay, so let me go back to our view, drop us down. This might be it. Okay, and I'll head west, young man. Okay, now we gotta wait the obligatory 11 seconds. Hey there, huh? Yeah. It is. It is cool. But you do get a lot of strange people that show up at all hours of the day saying, "Is that there a dome?" Yeah, it's a dome. Huh. Well, what you got in that there dome? Telescope? Oh, telescope dome. Yeah. You're like, uh-huh. And they're like, I guess, domes are kind of odd around here. Yeah. Kyle Lynch is in the house. Hey, Kyle. Okay, we're taking a photo of this cluster. Let's check it out. It should be in any second now. Here we come. Waiting. I'm just jumping the gun. I'm so anxious. Okay. Here it is. Look at that beautiful cluster. Wow. Amazing. Yeah, the moon is really bright in this area right now. It's obscuring a lot of the details in these clusters. But it's okay. It's still fun. Still good to look at. Alright. So, these clusters, again, all these stars formed at around the same time. The stars that are in this cluster. Most of these are in the cluster. When these... Hey, Daryl.
Hey, welcome back.
Yeah, welcome back. When the stars form there, they have mutual gravitational pulls that get orbiting each other. Some get ejected, over time. If you watched it, it would look like furious little fireflies. If you could watch a time lapse over a long period of time, you'd see these furious fireflies all dancing around each other. Some going away, some coming back, some going on these long orbits. And that's what would happen in a cluster like this one, when stars form in a cluster much like this one. So we see that, and it tells us a lot about the universe, because when we watch how stars form in a cluster like that, it gives us an idea of what happened with us. Now, our sun's all alone, and you might think, well, does that mean that we didn't form with anybody else? No, it absolutely doesn't. As a matter of fact, we did SkyTour Radio. We do a radio show. Daryl's a co-host with me, as well as Amanda Curran. And it's on Sunday nights from 8 to 10 p.m. on kgraradio.com. That's 8 p.m. Eastern Time. It starts. And it's all astronomy all the time. We talk about extraterrestrial life and the hunt for UFOs sometimes. Because I'm also the chief photo and video analyst for the Mutual UFO Network. That's like the biggest aerial anomaly organization on the planet. So we look for, when we talk about like where the sun comes from, because these stars, like you see right here, all formed in the same place. Okay, these guys, they all formed in the same place, and because they formed all in the same place, they are composed of the same chemical composition typically. And that chemical composition that you're seeing here, all these stars are going to be the same, right down to the smallest level, because all the stuff they were formed from in the cloud that they were formed from originally had a certain number of oxygen atoms, a certain number of hydrogen, helium, maybe some carbon, nitrogen, some phosphorus, some magnesium and calcium. And when the stars formed, they are formed from all the elements that were in those original clouds. And those elements came from previous stars that died and spewed their elements to the interstellar medium through the planetary nebula things we saw, where the stars doing this and sloughing off layers, to supernovae, which go boom and just blow their guts out to the universe. And over time, that stuff spreads out far and wide. So when we look at a place like this, we see stars that are forming, and their composition's all the same. Well, in order for us to find out where we formed and where the sun formed, we had to find other stars that were the same composition, not near the same, but exact composition as our sun. In other words, we needed to find, at the very least, the sun's twin. The sun's twin. And Daryl, I don't know if you remember that show, we actually did find the sun's twin. Remember that?
The KJRA show?
Mm-hmm.
Yes, I remember you talking about it.
We actually found the sun's twin. And it's a star that is, I forget how far away it was. We thought for a long time that we came, or were part of, as Daryl said on that show, the Ursa Major moving group, which is a bunch of stars in the what constitutes the Big Dipper, okay? And they're all moving at a certain distance, a certain way through space. That's called proper motion, the way it moves relative to us. And that motion was originally thought to be the same motion we had. It turns out it's not. So we're not in that same group. They just happen to be going by. Hi guys, okay, see ya. Okay. But so we're not in that group. We're moving one way, they're moving another. So that's not us. But then we thought there was this cluster that's about 2,500, 2,700 light years away that maybe we were part of. Because the stars were kind of similar. But it turns out that the mechanism that would have allowed us to survive and be ejected from that cluster and go that far away is the same mechanism that would have stripped all the gas from around that young sun and eliminated any possibility for planets to form. So that's not the thing. So where were we formed? We really don't know, But we do have a star out there that we found. It's way in the southern sky. In fact, it's down there, and it's quite far down south. And it's actually a star that has the identical composition as our sun. We found our twin. So, knowing the movement that it's gone through and the movement that we've gone through, it's possible to maybe kind of reverse engineer a little bit. But that's not going to give us all the answers we need. We're going to need to find a third or a fourth twin to both of us. And then we could probably figure out where we might have come from, which cluster out there like these we might have been part of, if any. It could be that we started as a cluster, but see how these stars are kind of separated and moving apart from each other? They started a lot closer and in orbit, and then they're getting farther and farther away with gravitational interactions. And so you're seeing a snapshot in time right here of these stars that are all in motion. And that snapshot is something that actually gives us an idea of where these stars are going and what they've been through, and we can kind of reverse engineer where they came from. Well, because we can see the members of this cluster. We don't have the members of our cluster. We have one cluster, right? One star that we know. And Daryl just said it, but I'll say it too. Hi, Donald Kunzer. How are you? So, I think it's kind of cool.
Something you said a minute ago triggered something in me. There is a really good channel on YouTube called Astrum, ASTRUM.
Okay.
Saw one of their videos a day or two ago. It says, "Is our sun inside a nebula?" And it turns out we are passing through a certain gas cloud, and they have a lot of detail about it. I won't get into it here, but I think you talking about the nebula we came from made me think of that.
Yeah.
It's worth your time if you're interested, people. Just look up the ASTRUM, Astrum channel on YouTube.
Excellent,
They
Thank you. That's cool.
have a ton of really interesting vids.
That's very cool. I think, if we're passing through a gas cloud, You have to keep in mind that over the last 4.6 billion years, our sun has gone just under 20 times around our galaxy in its orbit, because all stars are orbiting the galaxy. And in that time, a lot changes. Where there's a lot of interactions, there's a lot of things that come and go. Like the Ursa Major moving group, these stars, all relatively close to us, moving by us in the galaxy. And we're not following them. So it'd be really hard to reverse engineer 19 and a half revolutions around the galaxy to figure out where it was we were, say, on revolution 15 or revolution 6. I mean, that'd be really hard to figure out. But so in other words, we're traveling through the galaxy and through this gas cloud. Most likely this gas cloud is not the one we were born in, but it is kind of cool to talk about it. And there's a possibility that if we didn't go too far, that maybe we could kind of linger. But 4.6 billion years, that's a long time. There's a lot of interaction that is going on, you know. What's wrong with your chat, Daryl?
It didn't update. I had to refresh the screen.
Oh, okay.
I got that not so refresh feeling.
Hey, that's funny. All right, well, let's go see what we're doing here with the possibility that we might be able to go to Mars at the moment. I think Mars is now going to be M33 in Triangulum is beautiful, but it's not going to be very bright right now. So what I want to do is take us to Mars. Go to Mars. You want to go to Mars?
Sure.
We can make it to Mars, you know. All right, let's do that. There we are. And I might have to move the telescope one more time, but let's find out. Watch the stars as they go away here. They're gone because the telescope starts moving. And you can see it doing so down there in that lower thing there on the other side of the screen. See over there? Yeah, the telescope is heading out that way. And let's... What I like to do actually is I like to take us to... Oh, well, that's Mars. There it is. Yeah. We're having just a little bit of an issue with the guide scope because it's not quite lining up, but we got Mars. We have it. Okay, so let's go and Daryl, I don't know if you want to check where Phobos and Deimos are, Mars moons. If you want to look, that's great. If you don't want to...
I don't have a good source for that. Stellarium will show it, I believe.
Yeah, it does. Okay. All right. Let's drop this down. I can see that we probably have the edge of the dome in the way here. But let's just take a quick picture at 50 ISO. Okay, I can see Mars is kind of low in the sky. Let's just get a picture. There it is. It's low in the sky. But yeah, we have some focus work to do here. But first things first, we're going to actually rotate the image. That'll actually make it a little bigger. All right. Okay, you're going to have to refocus this. I can actually see we do have some black areas here. That's interesting, some darker areas. Let's take a look at where this appears to be. Let's go to Mars and look at what we're seeing here. Oh, wow. Well, we should have a large black area to that side, and it looks like Valles Marineris right there. And a white pale patch there.
The white pale patch is Hellas Basin, I believe.
It's Hellas Basin.
HELLAS, and that was Syrtis Major right above it.
Yep.
Looks like an upside-down Africa, sort of.
This guy here.
Yep. And that sort of club-shaped thing.
Isn't this
Valles
Marineris?
I believe it's called Terra Meridiani on the left. That's where the zero meridian of Mars passes through that. And the right part of that, I used to think the whole thing was Sinus Sabaeus, but Sinus Sabaeus is actually the right-hand part of it.
Okay. Oh, that's interesting. Look at this. You can actually click on... This is new. You can actually... Hellas Planitia. That's Hellas Planitia. But you can actually click on features on Mars now with Stellarium and actually get the names. That's pretty cool. This is Serranius Fossi. But... Where is... Let's see here. Degana, that's a crater, I think.
The best look at Mars I ever got was pretty much what you have up on the screen there.
That's beautiful. That's really pretty. Let me just take us back to this for a second. And then this. All right. Oh, come back. Okay, here we go. Okay, so let me get rid of this because we don't need our telescope view. Okay. Yeah, okay, so we have Tractus Catina. I guess we could just go on and on looking for features. It's kind of neat. Aram Chaos. Well, this is that. Let's just go see if we can see any of these details, Daryl.
Sure.
I don't know if we're gonna be able to though, but we're gonna try it. But first things first. Let's bring Mars in for focus a little bit, because if you notice, it's bouncing around quite madly. Yeah, that's how unstable the air is. You see it?
Yeah.
Well, let's give it a try. So here's what I'm doing. I'm going to focus now. It's going to take it way out of focus. And send it way into focus now. Back into focus. Okay, let's try that. Let's see if that actually did something. It's shaking around like mad, so it's probably not a good night for Mars, unfortunately. But you know what? I never say die. I never say die. Well, look at that, Daryl. Oh, wait. Sorry. Let me help you with that. There we go. Okay. So again, you can see that here. There's that dark area. And then we see this dark area over here. So we're seeing the accurate representation. Do you see that, Daryl?
I do.
I don't see the south polar cap.
It'll be down around 7 o'clock.
Yeah.
I might just barely see something there.
Okay. And I think
it's funny, the more I keep looking at that, the more I see.
Yeah. And I think this up here, and this is maximum size now. Okay, so we have this right here. Might be part of the polar hood, huh?
Could be, yes.
At this time of the season, Mars is going to have that vapor over the northern pole. And you can see a dark area right through here. And a dark area here. You know. And I guess that must be Hellas Planitia right here.
Yeah, down around 5 o'clock.
Yeah, do you see that?
Vaguely.
Yeah. But there is detail. It's better looking than I thought it was going to be.
Is this on the number 2 filter?
This is. Okay, this is number 2 filter, and we can go back and do the number 1 narrowband. And we found that sometimes the number 1 narrowband shows things even better. So let's go.
Reminds me, I got notice today that my Mars filter has shipped. Hopefully I'll have it in a few days.
Ooh, that's exciting.
Yeah.
That's as exciting as anything else, man. Okay, so I'm going to go a little longer exposure here. We're doing 50 ISO, so we're actually really low.
Yeah, it wasn't supposed to ship until October 9th, but
well, I'm glad it's shipped.
Evidently it's shipped. It'll be here before opposition.
Wow, that's fantastic. That's so good. Okay.
And the Altaz mount shipped a few days ago, and it arrived today and showed up right about dinner time before the show, and I opened it up and took a look at it. Haven't taken it out yet. Luckily, I have it's got a Vixen dovetail on it, and I already have a Vixen dovetail, and I have a set of tube rings for the refractor to fit that Vixen dovetail. I'm probably going to have to go out and buy a 3/8 16 stud to attach the mount to the surveyor's tripod I have.
Yeah.
May do that tomorrow. I need to search through the box and see if they already included one.
Oh, okay.
But oh boy.
I know, huh?
Oh yeah.
Yeah. Now, for those of you that were listening to Daryl speak this foreign language, I'm sure he would explain what the Altaz mount is all about, because there are people out there that actually probably don't know.
Okay. Altaz means altitude and azimuth. This is a manual mount. It is not motor driven. It simply pivots up and down in altitude and left and right in azimuth. Azimuth is along the horizon. Starts 0 degrees at due north, and when you swing 90 degrees to the right, you're looking due east, and 180 degrees is south, 270 is west, and another 90 degrees, and you're at 360 or back to 0, pointing due north. That's azimuth. Altitude is 0 at the horizon to 90 degrees straight up at the zenith. The telescope just rides in a cradle. If you ever saw pictures of my giant binoculars I built years ago, it's the same sort of mount. It's just slightly smaller. But you just move the telescope where you want to look, and then you have to nudge it occasionally to keep objects in the field of view. I got it as a simple grab-and-go mount for the refractor, so I don't have to go through all the BS of setting up one of the go-to mounts.
I think that's pretty cool.
I'll give a report once I get to try it.
Yeah, I was looking at it I was looking at what you bought. It was actually it's an investment. You know,
yeah,
it's pretty reasonable money. You know, not reasonable, but fair amount. Okay, this is with the narrowest narrowband filter.
Yeah,
it looks a little different from there, but you can still see what looks like the Hellas Planitia basin here.
Yep.
There's a large area up here that's just open. And maybe, I don't know, polar cap? Not sure. Not sure. Looks a little odd, but, I don't know. I think Mars is getting too close to me. I don't want to catch any Martian flu. Get away from me. Certainly. Yeah, that looks really pretty.
It's Mars, Mo.
It's Mars, Mo. Certainly. Yeah. Ow. Yeah. Blink. Remember those? I don't know. I could never work slapstick with Mo Howard, man. I'd be too afraid he would poke me in the real eyes, you know. For those of you that are fans of the Three Stooges, some of you may know that they really got hurt on some of these episodes. Mo was doing they were doing this wallpaper show, this wallpaper short, and Mo's standing on a table, and Curly's got a saw, and he cuts right through the table while he's cutting through something else, cutting a board or whatever. And he cuts through the table, and Mo turns a step and walk, and the table falls down, and Mo falls on his back and strikes the edge of the table as he falls. Obviously, that wasn't supposed to happen. Well, in that scene, Mo actually broke his ribs, but he continued for the rest of the scene until the director yelled cut, and then he collapsed and passed out.
Wow.
Talk about taking one for the team, huh? And then Larry.
That's what they call it, slapstick.
That's slapstick, all right, you know. And then yark, Tara. And then when what was it? Not Mo, but Larry Fine. Okay, he was actually doing I'm going to go back to the other filter, by the way. He was doing a scene where there was this paint that supposedly not paint, but a pen that supposedly writes on the whipped cream. And back then there were quill pens, you know, the point, you have to dip them in something and write. And so there was a scene where this thing was going, making whipped cream, and the pen shot out and sticks him in the forehead, and you hear like they always do. Trouble is, that was real. The pen really did stick him in the head, and he was actually crying out in real pain. But they left it in because it was hilariously real pain. Isn't that something?
Huh.
Yeah.
Hello, Dee Dee.
Dee Dee's here? Where? Where's Dee Dee? Dee Dee, how are you? Yeah, it's good to see you, Dee Dee. Thank you for joining us. We're looking at Mars. I'm going to drop down our exposure a little bit more. I'm going to try and coax out some detail on this red planet. Ooh. Look at that.
That's a little more obvious, I think.
That's actually a nice shot. Yeah. Hellas Planitia down here. Did you say Syrtis Major here?
According to Stellarium, Syrtis Major is on the right there.
Yeah.
And what I call Sinus Sabaeus, which you were giving different names in Stellarium. That's that right there. It's kind of a club shape.
Sinus Meridiani.
Yeah, the left-hand part is Sinus Meridiani.
Yeah.
That's where the zero latitude of Mars passes through. That would be analogous to the 0 hour and longitude on Earth, you know, passes through Greenwich, England.
Yeah. Well, this is Sinus Sabaeus right here.
Yes.
Yeah. So we have that.
And the right part of that is Sinus Sabaeus.
Yep. Very nice. And then I think that's right here.
Yep.
I think we can see that. Let me show you guys. So there we are. And what happened here? Is that right? Is that right? Hang on, let me get over there. Okay, we are. Right, so you're talking about Sinus Sabaeus being right here.
Yes.
And Meridiani's here. And then Hellas Planitia doesn't look that different now, but I mean, the more you look at this, when you look over here to the right, stuff on the left looks more clear. That's called averted vision. You catch more detail when you don't look straight at something. It works within telescopes and the eyepiece, and it also works with just objects when you're looking at them. And then this area up here, this white bald area up here, this is actually one of the northern plains on Mars. I'm not sure which one, but we can go figure that out in just a second. Let me pull this up. That is a Scandia. That's a crater. Okay, lots of craters. Holy cow.
Do you have that map I sent you the other day?
I might have that map you sent me the other day. I don't know where it is right now.
Okay, no worries.
But I can find it if I. Oh, see, we don't get any commercials. So how can I do it? We don't have commercial breaks, Daryl.
Yeah.
We'll be right back after these words. He goes to a commercial. Whoa, how'd that happen? Okay, let's see if I can grab more detail by cutting down the exposure a little bit. Let's go to a 25th of a second.
Great minds think alike. I was about to suggest that.
All right, and there we go. Let's see here. How about a little sharpening? That's sharpened. That's no sharpening. Actually, Hellas Planitia here looks more obvious.
Are we actually seeing some clouds there on the left side?
I don't.
A couple of whitish areas right there, and
I
then
know.
another farther down.
I don't know if those are clouds. What we'd have to do is stack a huge number of these images to see, because they would be persistent throughout all the images if they're artifacts. Marianne Robb, where have you been? We've been waiting for you the whole time.
Hello, Marianne.
Marianne is a great lady. Very helpful to me with SkyTour LiveStream West. Oh, that's a nice one. There's a nice shot. Look at that.
Could you try lowering your exposure time a little more?
Yeah, I could actually. That's just, again, great minds. I was thinking of dropping another couple of stops here to make it just at the edge. Maybe even more. Let's try this. Okay. I think I went too far now because we're getting... It's not... It looks like we're losing the detail now. It's getting muddy.
Yeah.
Went too far. See, I always go too far right when I should have gone the other way. Oh, here's a 30th of a second. That's probably optimum. 30th of a second is probably optimum. Hey there, Papa Tom. Marianne, it's nice of you to join us. I know that you have other things you have to do, too, as well. Marianne has been pulling her hair out, and she's bald now, fully, because she has been trying to get this entire observatory build going. And she is the eyes and ears in the West Coast here for SkyTour LiveStream, guys. So when SkyTour LiveStream goes live, we're going to be dedicating the name of the observatory, and the name is going to be, and I shall tell everybody now, it's going to be called the Hain-Robb Observatory. Hain is her maiden name, and Robb was her married name to Don Robb, who unfortunately was her husband, who has since passed away. So the observatory is going to be called the Hain-Robb Observatory in honor of both Don and Marianne and her efforts. And it didn't take anything for me to do that, because I think that she more than earned it. And she also earned something else, and that is she earned the STLSW license plate that she got for Arizona. She got an STLS SkyTour LiveStream West Observatory, license plate for her car. I mean, that's a good thing. I think that she really, really deserves that. After all her efforts, I could never do any of that myself. She went absolutely hog wild. Amazing. I'm going to keep taking photos because Mars is just getting higher in the sky. It's only going to get better.
Oh, yeah.
Yeah.
Oh, that one's nicer than the
That's
last
a
one, I
nice
think.
one. Yeah. This one here?
Yes.
Yeah, that's looking nice.
And I still see some white over on the left-hand side.
Yeah.
One down around 8 o'clock, and then
Right
another one
there.
up there at about
Right
9
there.
up to,
Up to 10?
oh, golly.
Or is it here?
Yeah.
You're talking about this right here?
Yeah, starting at about 9 o'clock and maybe moving all the way up to the North Polar Hood.
Yeah. Yeah, the North Polar Hood has got some weird things going on up there. That's pretty cool.
Yeah, I actually see some dark features just beneath the
Yep, right
Polar
there.
Hood, too.
Yeah, I'm not sure if that's an artifact or not. Yeah, you're right, Marianne. SkyTour LiveStream family are wonderful people. I would love for each and every one of you, I'd love to take you out to the SkyTour LiveStream site and actually show you what's going on out there. I think you'd really enjoy it. Wow.
Anytime but summertime.
Oh, come on. What, 115? You can't handle the heat?
No, thank you.
I can tell you this. I'd rather have that heat than that frigid cold. I can't deal with the cold. I was helping the scientist who owns the land that SkyTour LiveStream is going on, former Lawrence Livermore scientist, and he gave me access and permission to put this on his land with his wife. They're very good friends, and this observatory wouldn't be going in without them, obviously, too, of course. And Marianne, of course, is the one that's really making it happen. And one of the problems we had, and I'm going to mention it, Marianne, because I think that, it's just testament to the fact that you're working so freaking hog wild crazy on this project. We had a company that was going to actually build our observatory out in the desert. We've had a contract with them for 6 months to build this out there. Because of COVID, I've had to put off coming out there to work on the build with them. I didn't have COVID. I'm just saying that I couldn't go to Arizona to do it. I'm going to go up just a little longer, try this. 25th. And oh my. That's interesting up there. So what happened was they were supposed to come out and build this observatory to our custom specifications. It was in the contract. The roof is separate because the roof is going to roll off the building. Okay, they knew that. The building has to be a certain size. The walls are too big, but by the standard size, we want them cut down. We were told they could do that. And I accepted that they said they could do it. And then the next thing that happened was that we ended up, when they finally got in touch with me, they called me a couple days ago and said, okay, we're ready to come out and do your shed. I go, wait, this is an observatory. And the guy's like, what? Wait, the roof is supposed to be separate. Oh, yeah. It says so. I go, okay, so you're going to make it a separate roof. He goes, yeah, well, no, we can't. I go, what? You know it's supposed to be a separate roof. Yes. But you're saying you're not going to build it that way. No, we can't. What? And he says, yeah, no, all these trusses have to be linked to the walls. In fact, it's the trusses that hold the building together. I'm like, what part of this is a custom build built to suit the purchaser did you miss? And the guy was like, it's almost like he was not hearing me, and he was saying, I'm just keep taking pictures because this is really pretty. Maybe I was too far. And he was saying that maybe, if they come out, that maybe we can, maybe they could do some things. But I said, well, what about the door? Well, our doors are a standard size for like a personal walkthrough. I said, no, the walls aren't the height of a person. The walls are only 5 feet tall. Oh, we can't do that. He's acting like he was hearing this for the very first time. And I was like, you're not hearing this for the first time. you've heard this before. I've said this to you before. We've talked about it before. It's in the contract. And the guy's like, it's in the contract. We can't do it. So, trying to be strong-armed into doing something other than what I want, I then said, and I kind of said this at the beginning of the stream, I said, you know what? I think maybe you're not the right guys to do this. And I decided they're getting fired on the spot, that we're not going to use them. And in the interim, I was talking to another guy who lives in the desert right near this location and who's a brilliant builder but didn't have time. Well, now he has time. And he said, well, we can do this, this, and this, and I can make these walls, we can do that, and the whole building's going to be made of metal. It'll be a metal building, which is a very important thing in the desert where brush fires occur sometimes. The building will be impervious to being burned if a brush fire were to come through. So, I think one of the things that's going to happen is that this guy's going to build us a metal building out there. And that's underway. We've already got materials. He's got many of them in hand, and we're going to be getting more. Marianne is going to be getting more. She's doing it. And so we're fine. And, when you put many thousands of dollars of equipment into a building, you don't want like a stupid mistake to cause it to be lost, like a fire. So that's why we're doing it this way. There's really no building code saying we have to make it out of metal at all, actually, Gas Mask. But hey, Gas Mask, how you doing? And hi, Corey Williams. But it basically says that you can kind of build whatever you want. And out in the desert, you know what? There's really not a whole lot of oversight. You can kind of do what you want. But most people try to build for the environment. And we're going to. We have an environment where the building can get really warm during the day. It could get up to 130 degrees in there during the day, maybe more. And so what we're doing is we're making sure we're actually, it's all automated. The power to the building is cut at 5:30 in the morning, and it goes on at 5:30 at night automatically. And that means the computer comes up, and then after the power goes up, then the computer has a countdown timer that says if the building comes up, the power comes up at 5:30 in the evening, then the computer doesn't start until 6 p.m. Right, half hour later, and then the computer's ready for us to access, and then the whole building will have number one, power, computer access, and then we'll be able to go to town. But during the day, we'll be able to watch the all-sky cam. I have an all-sky cam, which I don't have running right now, actually, but I probably should. Because I unplugged the heater for it, which might mean that I'll see a dewy viewy, a dewy view. But if I go out to my main screen here, we'll come back and take some more pictures here in a minute. Let's go out.
You could see the South Polar Cap in that last image.
You could? Did I miss it?
It was a little more obvious. Is what the one white spot was. I thought it was a cloud down around 7 o'clock.
Okay.
It's South Polar Cap.
All right. I think, let me go back to here.
And it was a little more obvious on
your there screen. It is.
Yeah.
Duh.
A little more obvious on your screen than it was on the YouTube screen.
There's the South Polar Cap right there. Yay. That looks really cool. Let's see if we can get that again. Well, the other thing, too, by the way, guys, is that, all of these photos are made available to you. The best of the photos are. And look at that. You can't miss that South Polar Cap right there. Now that you said it, Daryl, it stands out like a sore thumb.
Yeah.
Wow.
Mark, question or suggestion?
Yeah.
Can you back off on the digital zoom just a little bit?
Yeah. I can.
Like that.
Is that good?
Does that actually help the resolution? I mean, can you see more now?
Well, the polar cap go on. You can see it better here, but I know what you're getting at.
Yeah.
I mean, clearly you can see the surface features. They're just beautiful. Hi there, Isabella. Thank you for coming and saying hello to us. Yep. That looks really nice. I mean, it stands out like a sore thumb. And it is, the South Polar Cap is really small at the moment. So to see it is really cool. Wow. That's nice. Yep. Yes, indeed. All right, let's see if we can come back here. I'm going to bring this up and I'm going to center it more. I'm going to center it more in the image here in the view. All right. And let's take a picture of that now. I'm doing 25th of a second, so I don't need to worry about the guiding, so I can take it at any time. And now what I'll do is go bring our image in. Here it comes. Wow, that's pretty interesting.
The South Polar Cap shows better at the greater zoom. I think those dark features actually show a little better, a little less so.
Maybe here they show better because, yeah, I mean, as you zoom out, obviously, you're not looking for detail. You're just looking for gross features, you know, coarse features, and this shows them.
Yeah.
Really cool. I hope you guys are enjoying us going through Mars and a couple of things here. We do have a large moon out there, so it is kind of a distraction. But for the record, I gotta say, maybe I should just take a look at the moon. If we can blow our vision away, though, our night vision. Yeah, if the moon won't be visible, I won't be able to. I'll have to move the dome to see the moon. I'd rather not move the dome to see the moon. So we'll stay on Mars then. What do you say to that?
I say alrighty then.
Alrighty then. Okay. So,
Vera, he can stack a few images. He tried. He did the other night. You ran a couple of clips of video, didn't you, Mark? And you picked the best images out of those.
Yeah, actually, I let Pip do that. Planetary
if you wait too long, Vera, the planet is rotating as we look at it, and actually it's slowly marching from left to right across the screen. And if you wait too long between images, it'll tend to smear the final image.
Yeah, so we'd have to take like video and do like 30 seconds of video, and if you're taking it 30 frames per second, then that's 900 separate frames that you can stack all together and make a final image from. Because if you think about it, each frame at this exposure right here, each of these frames can get stacked with each other. This is a frame. We're doing this manually right now by going, say, by here, go do a 25th of a second. All right, boom, we come back. So then this frame is there. Then we have this frame. Then we have this frame. I mean, I could stack all these images together, but the problem is that when you're trying to stack a single solitary object in a field of black, it really becomes hard. It really becomes hard. So you need a special tool. And the tool that I use is Planetary Image Preprocessor, PIPP. PIP. And it will take the video that you create and it will stack all those images together, and it will take out the bad ones. It will automatically sort them in order of quality. So I think that I'm gonna just do right now. I'm gonna do at this setting. I'm gonna do 30 seconds worth of video. Okay, video is underway. You can tell by the icon right there. Okay, we're going at a 25th of a second and at ISO 100. I should probably do ISO of 50. Because, but I guess for video I can't do less than that, so let's do it again. Okay. Alright, so let's start it again. And right now we're taking video, and so that video will be a little movie of Mars, really tiny, but we'll enlarge it and just stack one little segment. Okay.
Did you see the Mars images that Astro Backyard did a few days ago?
They're beautiful.
Yeah.
Yeah. Now he was using what, APO refractor, one of these very high-end refractors, I think. Okay.
No, actually, I think he was using a Celestron 11-inch Schmidt Cassegrain.
The HD.
Yeah, so Edge HD, yeah.
Yep.
And I think he said he was using a Barlow instead of an eyepiece for projection.
A Barlow, guys, is another lens you put in to magnify the view. Yeah, I think I remember that too.
Yeah, and he was using a planetary camera.
Yeah.
Which, it's surely too late to do anything about now. But if you're concerned about the length of the optical train and the back focal length of the telescope, the swing through and all that, this little planetary cam is a tiny little thing.
But I think I would still need a, when our telescope is on a fork mount, okay, it has...
yes, and that's why I mentioned swing through, yeah.
Yeah, I know, I'm talking to everybody here so they get it.
Oh, yeah, I know.
It's a fork mount, and the barrel goes up and down, and so when the telescope goes up to the North Pole, there's a base underneath it, and the camera has to swing through that. And if it is too long of a back measurement, it'll hit that, and that would really ruin your day. So what you do is you get rid of that fork mount and you go to what's called a gem mount, a German equatorial mount. Now you can put all manner of lengths of stuff back there, and the telescope swings a different way through the sky. They're automatic. They even, what happens when you go over the meridian, when you go over the center point, the telescope has to do a flip maneuver, where it actually, when it comes up, it can only go a certain amount of distance, okay? And then actually, if it's looking like this, it has to come up and has to actually flip over and go the other way to continue looking at objects. The only problem with that is that causes the objects to rotate in the field, and you gotta have a field rotator. It's another little thing that rotates the entire assembly. So you want a gem mount like that. It's a costly endeavor, especially for the equipment we have. So we're basically just working on the fork mount approach because it's compact and will allow us to do what we are continuing to do. I have this much clearance under my telescope, that much. It's about an inch. All right, and beyond that, I can't even afford to throw in another thing in there. I barely had room for the filter wheel, Daryl.
Oh, I know. Life is full of compromises.
It is. It is indeed.
If you used the field rotator, you could just use the telescope in Altaz mode. In fact, Meade, when some of their larger Schmidt Casses some years ago, they were selling their telescopes in Altaz mode, and they offered a field rotator along with it.
Yeah, that's the 16 that they offer that way.
Yeah.
Boy, that'd be a great telescope to have in an observatory. Is a 16-inch Meade. Oh,
Yeah, you're talking big bucks there.
I think we're talking about $20,000.
Yeah, if you trusted your mount, or that once you did an alignment and you had north, and you were aligned on the celestial sphere and all that. If you maybe were going to dedicate a night to planetary observing, I'm just saying, I'm not suggesting. Once you swung the telescope away from north to your target object, you could, I would think, change the setup, where you have more back focal length available then, and like say slip a different setup on.
Oh, I agree with you.
Yeah.
I mean, that's where a turret, even if it's custom engineered.
Oh yeah.
I've seen some of these turrets that are just phenomenal. And when I talk about turrets, at the end of the, you know what? Maybe it helps if I can show. Go back here. No. Yeah, I can. This will be good. I'll show this for a minute. Oh, there we go. That'll work. All right, let's go and let's explore the telescope. So here's the barrel of the telescope right here. Do you guys see this barrel? Okay, here's the barrel. Okay, this is one fork. You're seeing it from the bottom, looking up along the fork as it goes away. The other one's on the other side. You can't really see it. This is the back end of the telescope. This is the filter wheel right here. Okay, and this is the camera sticking off the back. This leaves me an inch to go underneath these forks when the telescope is looking up there or higher in the sky, because this base really is sticking up, and the telescope has to swing those things through, to actually work. Well, the bottom line is that we don't want, to compromise what we're looking at in the sky. We want to be able to look at things, but we only have a certain amount of stuff we can put in there, and so. If we had an equatorial mount, it would mean that this entire assembly you're seeing here, these forks, all that would go away. And this would be mounted on a long axis that has a big counterweight on it, and it goes in two directions. And the complications are legend with equatorial mounts. But they were really meant for very large telescopes that needed to have a long back focus, meaning you have to focus way into the back. In other words, when I put something on this telescope, okay, the camera's right here. It focuses right there in that camera. Right there is where the light comes in and focuses. But what if I needed like the camera that had to focus out here somewhere, some way out, or even out here? I couldn't do it because this is got an inch clearance to the base of the telescope. Beyond that, it hit. So I wouldn't be able to look at certain things in the sky. I'd have to specify what's called the mount upper limit and the mount lower limit. And that would say, telescope can't go look higher than this, okay? Because then it would bump into things. If I wanted to do that, if I specified these limits, then I could, in fact, then put something on there. But we would never, ever be able to look at things, in certain spots in the sky. So rather than do that, we're sticking with the stock setup, and I think that's going to work better for us. It's otherwise very expensive, and otherwise going to be a tough road to hoe, actually, to do that. I like the idea. I'd like to do that, but not with this telescope. We'll do that with maybe one of the other piers in the building. Yeah.
You mentioned turrets.
Yeah, I kind of got off. You're right. Sorry.
I think I mentioned Paul Van Slyke, the guy who ran Black Forest Observatory just north of town here.
Okay.
He ran a machine shop, and he manufactured astronomical accessories, real high-end stuff, and he offered several turrets. Had one on the back end of his scope. It was a 40-inch telescope, a huge telescope he built himself, and he could rotate like 5 or 6 different things on the turret to bring different eyepieces or cameras or whatever into the focal plane. But I bet just the turret assembly probably cost more than your telescope did.
I bet.
Again, I mean, these were real high dollar items.
Yeah, I mean, and when you look here at the end of the telescope, this is where the camera is. But if your camera is one of the things you want to have in this focal plane, this is the focal plane is right down here. This is the optical path. This is the optical path right here, all the way up to the end of the telescope. All the way up there. Okay, light comes in, bounces off the mirror, hits a secondary mirror up here, and then bounces through a hole in this back mirror and comes out here. And this is your optical train. This is like where all the light's coming in. Well, if you want a camera here taking pictures, that's great. But what if you want now a different camera? You can't put another camera on because this is taking up the space. So what you do is you have a turret here that rotates the next thing through. Ka-ching, 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 ka-ching. Like a tool head in the machine shop with a CNC machine that has all these fancy rotators. That's the kind of thing that you put on here. So I could rotate our spectrograph in. I could rotate a camera in like this. I could rotate a specialty system in that does just planetary photography. So in other words, now we're going from $10,000 of telescope and accessories up to $40,000, and that's easily. And that's the kind of thing that I would do if I got a foundation grant. I would actually create an observatory or more. I mean, this is the Connecticut Observatory. We're putting another instrument in here when this whole assembly is going to Arizona. All this you see goes to Arizona, except the dome. And once I have confirmation that our building is a certain percentage finished, I'm going to pack this all up, and you'll never see the Connecticut skies through this telescope again. It'll only be the Arizona skies. And if we can get a foundation to support us, then what we're going to do is we're going to go and do all those things I just said. We're going to make a turret telescope that's actually going to rotate different instruments through. I've got instruments to actually put on there. And then,
cool.
And then we're going to get other telescopes to put in the dome in that building, if not build other buildings in different locations. Now, this area that we have access to is a 5-acre flat spread, okay? And I don't know if the owner would want to have more than one building on that property, but if he did and didn't mind, then I would put another building in there. That other building would be a building that would have the same layout, the same style of operation, the same work, but it would be much more involved. It'd probably be 30 by 20 in size, not 12 by 12 like this one, okay, is going to be. And 30 by 20 would have many pier mounts in there, many pads. The entire roof would be a very large not hemispherical, but a half-round roof that would roll off the building, just like down in Cerro Tololo in Chile. There's a building where the roof rolls off, and you got like 20 telescopes. They're all remote, and they're robotic cameras. It's a robotic exoplanet search system, and man, it's really cool.
Is that the clamshell dome?
No, it's actually it's not a clamshell at all. It's actually a very long building with a very large roof, a square roof that just rolls off, and it exposes 12 telescopes that are robotic. And there's a beautiful video online. You can watch all the telescopes operating through the course of a night, and they're all going every which way. They put music to it, and you see the telescopes all moving around. It's so cool. Very cool.
For your needs, there's one other thing you can do.
Yes?
Star diagonal.
I have a star diagonal, and I thought of that.
My concern there would be flexure in the optical train.
Yes, and what he's talking about is if there's little flecks and things move, guys, that could be a problematic thing. Now, what's a star diagonal? It's a right angle prism. So instead of going back and then bumping the bottom when you try to come up, you can actually come back and then go up, and your camera will be facing downward. And you could actually have a larger system up there. The only problem is that star diagonals, as great as they are more glass that you're looking through. Loss of optical quality, however small, will be perceptible. And there are some star diagonals that are very, very high quality. And for all intents and purposes, we could probably get one that we would not at all know the difference as far as it looks. It would probably be just as good.
A lot of them nowadays are mirrored instead of prisms.
Yes.
And they have reflectivity of 99%.
Yeah.
But still, as you said, I mean, I discovered this with the giant binos when I built them. You take several mirrors and put in the optical train, which I did for the binocular adapter, the eyepiece adapter.
Yep.
You multiply 99 by 99 by 99 by 99, and all of a sudden you're down in the 80% range,
Yeah.
Let's look at Mars.
Yeah, I know. I'm looking at Mars now. I just gotta let's see what we're on. Narrowband number 2. So it says narrowband number 2 right there at the bottom. And we're gonna do a 25th of a second, 50 ISO. Yeah, let's take a look. Oh, wait a minute. There we are. So some of the features are changing as we keep looking at them here. Neat. Anahata, you're so sweet. I'm buying a lotto ticket for you tomorrow. Yeah. Actually, that would make it so I didn't have to worry about, producing for a foundation. But I would, because I know I could do this outreach like this. One of the other things we're talking about is a traveling observatory where we would actually go around the country to different places and college campuses, campi, and showing them astronomy dynamically with a observatory in tow behind like an RV system. And we'd set it up. It'd be a portable observatory. People can come check it out. And we would have a viewing location. It would come out and pop out, and people could sit and watch on the screens, and even walk up and look through eyepieces, like old-time astronomers have done throughout history.
Like me.
Well, and me, yeah.
I've seen mobile observatories like that. People build them in RVs or travel trailers and such, and they pull up and they level the trailer, and usually the telescope is on like a pier. They can lower it down to ground level and level it, and the roof opens up, and you got a pretty decent aperture telescope inside that thing.
Yeah, I have a design already. I've been working on, and some of the fancier RVs, they have these auto leveling systems, and so they're feet that come down and they automatically level the entire building and the entire RV. Well, this would do the same thing for the observatory. It's a trailer, and you when you get to your location, you disconnect it from the RV, because as soon as you go into the RV, it's gonna make everything move. You disconnect it, you just take it out, take the pin out, and crank it, do what you got to do, but it's going to be done automatically. It won't have any involvement required. It can be done in a 10 below zero setting, where it'll automatically level itself, automatically disconnect from the trailer, or the towing RV kind of thing, and then you will be able to automatically access it from in the RV and run it from there if you had to. The other thing is you could actually then do the idea is you can actually go in a building and run it from in the building on any computer, because any computer could access and log into the observatory. That's the whole point. My telescope here, I'm logged into this computer that you've seen this image because of the courtesy of the computer out there that I'm logged into. And I'm logged into it. I operate it as if I'm sitting in front of it. I've slaved it. So, and look, I mean, it doesn't produce some that's not bad views. Look at the polar cap there. That's pretty nice. You know? I keep taking pictures. I did take 30 seconds. I'm going to get it off the camera as well. Some of these, you know, you catch the seeing at just the right moment, and look what you get.
Yes.
This isn't bad. I think this rivals the first night we looked, thought it was really nice.
It does.
In fact, it might be better.
Yeah. At least equal, if not a little better.
Yeah. Really cool. Wow. Okay. And let's go to a 30th of a second again. Okay, clearly the polar hood is there. There's some line up here.
Mm-hmm.
And that's consistent, and it's consistently showing up in all these images. So I want to know what that is. So let's see if Stellarium knows anything about it. Well, Stellarium wouldn't know anything about it if it was an atmospheric thing.
If it's dark, it's a surface feature, I would say.
Yeah, it is dark. Maybe it's this feature here we're seeing. See this line right here?
What I see is right under the word distinguished.
Yeah, not sure if that's the same thing. Let's take a look. Yeah, see, it's something that goes all the way from over here, all the way to over here.
Mm-hmm.
That could be this right here, this whole area being melded together. You see what I mean?
Yeah.
Well, that's pretty cool. And then the polar hood is in that area as well. South polar cap down here. Hellas Planitia. Okay. Yeah. Lots changed already. See, look at now we have what's this here coming around the corner? Ooze Boy Valus that's this guy, and then this guy here, Eos Mensa. Wow. Very cool. Tiny Chaos. Wow, this is neat stuff. So, it's kind of fun to look at Mars and check things out. Vera, the music, isn't that cool? It's all new music. I got all new music for SkyTour LiveStream. I like it. You know, it's actually been... Some of these are very long cuts, but they don't have to be. I mean, I do have other cuts, you know, like this, you know. So this is kind of cool too, you know. We can really go crazy with music, you know. But I tend to have music playing no matter what I do. When I do a talk, like I've spoken all over the world, and I like to play music when I talk. And it's part of the reason is because it gives you time, and you don't have to rush. You know, you can talk, and if the music is in the background, just cruising along with you like these other cuts were, then it'd be really nice, and I don't feel like I need to fill every second. Because you have something to listen to. Look at that, Daryl. I think that's... I'm thinking that's definitely a feature up there.
It is. I went back and looked at those maps I found recently.
Okay.
I have one high-quality map put out by National Geographic, and it clearly shows that dark line just under the polar hood.
Awesome. Okay. So we
I
are
can
there.
send it to you if you want it.
Yeah, please. And look, this is that other one that maybe you were talking about.
Uh-huh. Let me go find it again here.
Okay. Yeah, just pop it into Skype, and I can bring it up in the view here for folks to see. All right, let's... .25th of a second again. See, the atmospheric scintillation and the atmospheric disturbance that you're looking at will tend to make Mars dance around, but the higher it gets in the sky, the less that's going to happen. So, for instance, okay, we have our focus window open. Oh, thank you, Daryl. I'm going to go put that up for folks. We have our focus window open right now, and I'll bring Mars over so you can see what's going on with it. Okay, so this is the live view of Mars. Okay, see how it's dancing? You have to catch it. You catch it at just the right moment. It's not the telescope doing this. The telescope is rock steady. All right? I have zero wind in the dome right now. And what we're seeing is the fact that the atmosphere, which has these cells of warm air and cold air, as those cells of warm air and cold air are moving, they will disrupt the images. In the same way that if you look at hot air rising off of a road, it causes a ripple effect that makes like a rippling effect of distant objects. Well, in the same way, Mars is a very distant object, and we're going to get a rippling effect of that too. Whether it's heat or cold, they both can do damage to the image. All right, so let's close down our focus. You can see how it was moving around. Let's do another shot here, and it's going to necessitate bringing Mars back in. Wow. That's looking pretty interesting. I like when Mars is not, as far away as it normally gets. Yeah.
I think tantalizing is the word.
Tantalizing. Yeah, for sure. For sure, it's tantalizing. No doubt about it.
I see differences from image to image as you shoot them. Some over near the right-hand edge, there's kind of a notch in the dark, and you can see quite a little light-colored.
This area?
Yeah, above that.
Right
just
up
above it, right there. There's sort of a light-colored notch going down into the dark. I assume that's the boundary between Sinus Meridiani and Sinus Sebaeus, and then the notch goes down between that and Syrtis Major. Syrtis Major is kind of going off the right edge of it now.
Okay. So let's see here. Let's go to here. Yeah, let's open it. Let's see if I don't want to open that here. Oh, good. Yes, I do. Okay, so let's okay, here's what I'm gonna do. I'm going to go over here to our remote view. Okay, I got this, I got that. Okay, now here we are. I'm going to take the dome cam out of the picture for the moment, and let's see if I can get us yeah, that's what I want, but it's got the wrong thing going on. Let me get rid of the logo. That's our new logo, by the way. And let's look at this. And let's get rid of the welcome, because you already are welcomed. You know you're welcome. You're welcome. And now let's go over and look at the image proper. There we go. Okay, so we were seeing Hellas Planitia down here, and then we have Syrtis Major up here.
Yeah, which is near the right edge now.
Yeah, near the right edge.
And
quite
that light-colored notch I was talking about is there just immediately to the lower left of Syrtis Major.
This here?
Yep.
Okay.
And that's showing up pretty clearly on some of your images.
Yeah, it is. And if we go back to this guy, hey, what are you doing down there? Let me just, oh, that's the live view, sorry. Let's take another view, take another shot. Okay.
Yep, there it is.
Right here.
I see a little dark line in that notch there.
Right
I don't know if that's real or not.
That thing?
Yeah.
Yeah, I don't know. That looks like it's not real. I mean, previous one, is it there? Almost. I mean, it might just be. It might just be. Okay. So let's go take another picture right now. Yeah, I think it was. I don't think that's.
Okay, might have just been pixelation, perhaps.
I think that's what it is, actually. I think that's.
Yeah, you can see that light-colored notch kind of going down between Sinus Sebaeus and Syrtis Major. Syrtis Major is right on the right-hand edge now, and it's foreshortening as it goes around the curve of the planet, sphere of the planet.
Yeah.
But you can see that light-colored wedge kind of going down and to the right.
Right here. Right here, you're talking about.
Yeah, and then looking left to center on that map, that's corresponding roughly to what we see as the big dark area.
This here?
Uh-huh.
Yeah,
all that higher up.
That's Meridiani.
Then if you look just beneath the North Polar Cap there, you can see that dark line going all the way around we talked about.
Yeah, we saw that for sure. Yeah, we did. So right now we should be able to see Valles Marineris coming around, or some kind of indicator of Valles Marineris, but it'll probably get lost in this this stuff here. Well, let me show you what I mean, because you can't really see me doing this. You see Valles Marineris is coming around now. Here's the dark line that we think we're seeing, and then we have the Acetalia, Planitia here, Christ Planitia. The Viking is one of the Vikings is in Christ Planitia, I believe. And Valles Marineris right there, the biggest valley in the solar system.
Yeah.
All right, and the polar cap on Mars is definitely not as big as it shows here. At the south, it's a little bit smaller than that, but it is underneath this polar cap, south polar cap, where water has been found. About effectively like a mile below the surface or so. And it's like a 12-kilometer long lake underneath. It's really cool. All right, let's go back to our view. And let's see what we've got here. This looks pretty. All right. So let's go back and do one thing very important here. Take another shot. Yeah, that dark line definitely does seem to stand out, doesn't it?
Mm-hmm.
Very cool. Wow. Now, what do you got for altitude here on Mars? Our azimuth it's at 45 degrees now. Wow, when we started it was like 28, now it's at 45.
Altitude or azimuth?
Altitude.
Okay.
Yeah, because the azimuth's 135. The
Yeah.
altitude's plus 45 right now. Very cool.
That's probably about as high as it's going to get, I would think. Might gain a little bit.
Yeah. Well, we're seeing it as best we can see it with the moon and everything else. Not bad.
Uh-huh.
Yep.
As I said, tantalizing. I'm seeing hints of fine detail on that. On the big dark blob, a little left of center up toward the dark edge, I see one dark knob poking up and another with a little light space in between them, a smaller kind of a wedge in between them.
Mm-hmm. Like right here.
Yep.
Yep. I see modeling in this section.
Yes, so do I. And I can still make out the South Polar Cap, barely.
That's right there. Actually, where's Phobos and Deimos? Did we look and see? You have to look and see. Let's go see. Let's back out of this a little. Okay. Oh, there we go. Phobos and Deimos are actually kind of in a line like that to that limb of the planet. So if we overexpose Mars, we should actually be able to see Phobos about 3/4 of a Mars width away, and Deimos a full Mars width away.
Yeah.
So let's do that. Let's take a long exposure to grab it. See if we can catch them. Okay, we'll do a 5-second shot. See if that works. Hopefully it doesn't make too much or too many overexposed areas. What do we got here? Okay, so not enough, I guess. So we're gonna go. Remember, I'm doing this with. I am using filter number 2, narrowband 2. So let's go back and let's increase this to 20 seconds. That could be too much, but we'll see. All right, 20 seconds at the lowest sensitivity. I probably should be up around 400 because 50 might be too low for the sensitivity. Mars looks like a star. Okay, I'm going to increase our sensitivity here. I'm sorry, increase our ISO. 400 looks. Try 400 for 15 seconds. Yep. with the narrowband filters, moons sometimes are lost. And with the moon so close to Mars right now, I would not be able to get away with taking a white light photo. That is one without any... oh, we got something. I wonder if that's a star or if that's Deimos. Yeah, that's got to be a star because it's way too far away. I don't know. I can't do the white light shot because the moon will prevent it. But
right.
All right. So what I'll do then, we'll just try one more shot here. Mars. Let's drop it down. Drop this down. Okay, and okay, we're gonna do this now. We're gonna drop this down. Okay, 15th, 20th of a second. Wow. That looks pretty cool.
Mm-hmm.
Now, clearly you're seeing northern polar cap region and that dark area up top.
Yep, and I still see the two dark bumps at the upper left of the dark blotch and a little light wedge in between them.
Yeah. Only with astronomy can someone say, and I still see the two dark bumps by the light wedge. I mean... It's hilarious to hear it. You know, if nobody knows what you're talking about, they're going to go, what in the heck is he talking about? You know?
Well, just describing the contour line of the...
Yeah, I know. But it's just like, only in astronomy would you say things like that and everybody else goes, yeah, of course, yeah, I see it. And you're like, what the heck? You know? People who don't know. Anyway. Okay. Okay, come back a little smaller here, a little lower exposure. Wow.
It really changes moment to moment.
Yeah, it does, you know, and that's why PIP is going to be so important. Actually, I should do another, now that it's 45 degrees, I should, and I will, I'm going to do it again. I'm going to take another 30 seconds of it here. There it is. I hope you guys are enjoying this tonight. We have been having a good time. Amanda couldn't join us. I guess she's busy. And we will be back at it again, you know, once we get another clear sky. Hey there, Astanex. How are you? Okay, that's about 30 seconds. I'll be downloading that specifically. Oh, Isabella, that black and white version listed, there's actually two different versions there. I hate how Amazon does that, but it's there. I have to see if I can show you. I'm unprepared. I can't show her. It's there, Isabella. It is there. Oh, sorry, Astynex, you can't sleep. Yeah, unfortunately, well, this is Mars. I mean, look at the detail on Mars. We can see some really cool stuff. That little white dot there is the polar cap, the south polar cap. We're seeing some of the features on Mars here. There's a white, this is called the polar hood, which is over the north pole of Mars right now. There's a dark area right below that, which is very clear. Yeah, Isabella, it says black and white, but if you look very closely at that central area where you can see that there's another version of the book you can pick, and it will take you to the full color one. I don't know why they do that way. There's the Kindle version, and then of course there's the black and white version. But it's really the full color version is the one you want. Hey there, Adam. Adam Lorber's in the house. How you doing, Adam? Thanks for joining, coming out. We're actually winding down. We're looking at Mars right now, as you can see. And it looks really nice. We're getting some gorgeous detail in Mars surface area. And, you know, if you look carefully, you can see the polar cap is right here. It's kind of hard to see it, I think. But then we have other detail here. And you got the white, the polar hood here. This is the area around the top of Mars where the North Polar cap is shrouded right now. And then we have some features that are coming around here. Mars is rotating that way, you know. It's coming around this way, you know. So it's like really going like this way. Okay. And we're seeing these features, these beautiful areas here. We've actually identified, Daryl was kind enough to send me this gorgeous map of Mars that shows us what we're looking at. And so this map is something that it's the National Geographic map of Mars. Beautiful. Thank you for that, Daryl. That's a really good map.
Sure, no problem.
Yeah. Ooh, gotta move away. It's a little warm over here. So yeah, Mars is looking pretty good. I just did more video of it, and we're gonna take each of those video frames and we're gonna stack them with each other and throw away bad frames. I've got about 1,000 frames that I have right now in the video, and you know, we only have to stack about 30 or 40, so out of 1,000 I think I'll have plenty. I average about 500 that I stack when it comes to planets, and it's really cool. But anyway, I am rapidly approaching the fatigue limit for me tonight. I have a lot going on, as you can imagine, and I will be managing the observatory build with Marianne Robb again tomorrow, and seeing where we're, what's next. I've got pictures we got to be taking. I have all kinds of presents out there to see what's going on. Yeah, and the Mars is purple, by the way, because of the filter. You know, I guess just for fun before I go. See, I'm marked just one more, D'Antonio. I guess how it works. If I just take us now to the spectral band, let me just do that. Go here. So there's a spectrum of Mars, and then if I take us here, okay, there's Mars in the spectral band. You can see the obvious lack of blue light. Mars is reflecting mostly into this realm, but if you look at the reflection of light again, you're going to see mostly the sun's spectrum, known as the Fraunhofer Spectrum, because it's reflecting sunlight. All right, but if we then go, the next one is just a dark disk for dark frames. But then this next one is the white light frame, and that kind of gives you a more realistic look at Mars. But because we're doing such a small, I have to refocus too, by the way, and we'll do it. Why not? You know, like I said, one more. One more. I never get tired of just doing one more for you guys. You guys are really, it's really cool. All right, so let's bring it over here, and then up there, and that's more of the realistic color of Mars. Wow, even in this live view, Daryl, you can see details when the seeing is good. I have to refocus now. That's way out of focus. And we'll come way into focus. Let's try that. 50th of a second. Let's see what we get. How did it work? And did it work? Well, you can see the benefit of filters here. Okay, let's go back. So that's what that looked like. Not too exciting. The filtered views are much better. But
see the South Polar Cap.
Yeah. I think I gotta focus better on this right now. So I'm gonna do this now. We're gonna do the focus routine again. Okay, you're out. And in. Okay, and let's drop this exposure down even more to say this will be 100th of a second. So we're really going to freeze this action. Let's do this and this.
Just a little bit.
Yeah, but you notice how much the filters do so much of a better job.
They do.
You know, when we look at it, we see so much of a better job. Like here, you zoom in on this, okay, and we can see actually this one. You can see a lot more detail, and the polar cap stands out like a sore thumb. But when you actually look at the white light shot, okay, it doesn't have that same appeal.
Yeah.
It has the right color for Mars, but it doesn't have all the detail. So this is the value of filters, guys.
Can you go back to that last filtered shot you showed?
Yep.
I think I see a break in the South Polar Cap. Over on the left-hand side of it, I see a thin, dark line.
Right there?
Yes.
I see that. I don't know if that thin, dark line is real or Memorex.
Mm-hmm.
Might be an artifact, but the stacked image will show for sure.
Cool. Share, please, if you get a good one.
Oh, you betcha.
Oh, yeah, I'm sure.
Yeah. Ask the next, you know what you can do, and to the rest of you as well. I don't know if you can get an autograph through it, but you know what? I do a lot of conferences, and actually, if you wanted to send the book to me, I'll write you a very nice notation on it. I won't just sign, but I'll say something rather interesting, I would hope, and that would definitely, if you want to do that, if you want to do that, I'd be happy to do that for you. If you guys go through the effort to get the book, and I go through the effort to make sure I figure out a way to sign it for you, and I know because of COVID, no one's doing conferences right now, but once they start up again, I will be going to all kinds of conferences. I actually just did a conference in New York State already, just a few weeks ago. And I was the only live. I was the only one doing a live presentation. The rest were all through remote, But I figured if people are spending money to, go to a conference, then I should go to the conference and be there physically. I don't think that doing a remote. I understand safety, but I felt that people going to the conference, they deserve something more than just a Zoom call or a Skype call. Now, the other people that were speaking couldn't actually go. They had to do it that way, or they couldn't have done it at all. So that's okay for them. I know them both. They're very good people. They feel kind of the same way. But, some of these conferences that are remote, they may not do very well, because it's like watching a YouTube video, and you're doing it in a chair in your office or your house, and kids running around if you got kids that are young, or dogs or cats, and it becomes a problem. So in any case, I felt that if people are spending the time and effort to get someplace, then I should spend the time and effort to get there as well. So I went to New York. I did the conference there, and it was very well received. People really enjoyed it, and I was very pleased and very happy that I went and did it. So that said, it's sort of odd because I do the observatory remotely, right? But I can't bring the eyepiece to all of your eyes. I have to do it this way. And it is the way it is. This way I can share the universe with all of you. And man, it's crazy good. It's crazy beautiful out there. That said, we'll call it a night tonight. This has been a really, really good night. Mars actually has performed very well. Daryl, you agree?
Yes, I do.
Yeah,
Really, this is nice. Good or better than the last really good view we got, the first view we got.
That's right. Adam Lorber asked, where would I do it in New York? I didn't go to New York City for this. I actually did. I went to Pine Bush, the town of Crawford, and there was a conference there, and it's been growing, and it was very, very nice turnout in spite of COVID. So it was really cool. And my last time I spoke there, I was asked to speak there at the museum nearby, and people drove up from New York City to watch the talk. I mean, that's a couple hours, an hour and a half at least, right? From there, that's a long way. So knowing that people drove that far, I gave them extra time, and I stayed longer, and I stayed after, and I made sure that they got a chance to exhaust me with their questions, because again, if people go through the effort to do that, I wouldn't be fair of me to just get in my car and go home like after I speak for an hour. No way. I felt like I should stay longer and talk to these guys, because if they're interested in me, I'm interested in them. I want to hear what they have to say. So anyway, you guys, you have a good night. I hope that we can continue this again. The next time we talk, I'll be I don't know, it depends on the weather. I might be here, I might not be. I might be out west. So, but we'll talk soon, and I will do another SkyTour LiveStream if we can. Otherwise, if the observatory build starts up in the next day or so, continues and gets finished in the next week or two, then this might be the last stream from this equipment here in Connecticut. And then we'll have other equipment that we're going to put in. And we'll go back to having a Connecticut observatory, and then we'll have our Arizona observatory. Now that's cool. Have one on both coasts. Now, isn't that cool? And maybe we'll have another one. And our plans are legendary. If you talk to Marianne, we're going to be all over the world. Okay, because she's got all these crazy, really crazy good ideas. But we'll see how it goes. In any case, one step at a time, guys. one step at a time. What started as a 20-degree time in the dome spent showing you an hour of the sky has led to a full remote system, which has now led to an Arizona presence and a Connecticut presence. It's growing. It's growing. And it's growing because of you. You down there. You all. And I am grateful to all of you. And I'm grateful to Daryl for spending the time with us. I'm grateful for Amanda Curran, who's my co-host with Daryl on SkyTour Radio, on KGRA Radio on Sunday nights. And so, but we'll be back. So guys, see you later. Have a good evening. And remember, when you go outside, keep looking up. Good night.
Good night, everybody.
See you later.